And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Live.
Okay, it looks like we're live. We are in for a treat tonight, guys. We've got Erica, who goes by Gutsick Gibbon on YouTube. Be sure to check her out. And John Maddox, who goes by Logical, Probable, and Plausible on YouTube. So make sure you check him out as well. This is the much anticipated debate on intelligent design. So it looks like we've already got a lot of viewers in the chat today. So it's a blessing because I have brother Sal here. He's no stranger, and neither is John and Erica. So we're going to have a good show tonight. Brother Sal, thanks for co-moderating with me tonight. He's going to be in charge of the Q&A. So guys, like I said, we've got a big chat tonight. So just make sure you tag Salvador Cordova. We don't want to miss your question. We'll make sure that we save it, and we'll have a good Q&A at the end. So we've got a little formal and informal debate tonight. We've got about 10-minute openings followed by a discussion and quick closings, and then a Q&A, like I said. So make sure you're tagging Sal. Before we go into the openings, though, let's kind of break the ice. Both Eric and John, no strangers to debate or this channel. But let's start off with you, John. Give us a brief introduction. How you doing? You know, how's your channel? Go ahead.
Oh, doing good. Thanks for having me on. Looking forward to this conversation. I'm a little more tired than I would have expected. Just got done with a debate over on modern day debate, but looking forward to this one. Should be a good time. My channel's kind of directed a combination of both intelligent design as well as addressing some of the issues that I think atheists suffer from in regards to their mental positions and worldview and how it leads them to irrational conclusions. But tonight we're going to be discussing intelligent design, and I think it should be a good time.
Awesome. Thanks for that, John, and much appreciated. Thanks for giving us your time, even though you're as tired as you are. So over to you, Erica.
No, yeah, absolutely. Thanks for being here, John. Let's see. My name is Erica, go by Gutsick Gibbon on YouTube. I run a channel that covers a lot of paleontology, anthropology, things like that, and a lot of creationist content that I kind of try to get a deeper look into and kind of dissect. But I'm very excited to be here. No real news on my channel, but I did get engaged in real life, so that's kind of fun and
congratulations. That's awesome.
Thank you. Yeah, I'm very happy about it. So, but man, it's almost up there with having a conversation on intelligent design here on the SFT channel.
Well, it's an honor that the announcement of your engagement has occurred on SFT. So that's awesome. Congratulations. We're happy for you.
Yeah, thank you.
No problem. It looks like we already have questions coming in for you, Sal. So you're going to be busy tonight. It's why we pay you the big bucks, though.
the biggest
guys in the chat. Yeah, make sure you're tagging Sal. And my apologies. I'm not too sure who is starting. Whoever wants to volunteer, I guess, and then I can put the timer. Up to you guys.
It doesn't matter to me.
Yeah, I don't care either. It's you can go first, John. I will cede that to you if you'd like it.
Perfect. Okay, John, no rush. I know you have a presentation. We got Praise here, our wonderful producer. Of course, brother. No rush. Couple quick announcements. This Wednesday at 3, check out a Marvel Girls channel. I'll be debating conspiracy cats for round 2 on Ancestry, so that should be fun. And we've got Kent Hovind and Ron Garrett. I believe, I got to double check, but I believe it's July 9th at 9 EST. So we've got a lot of good debates this month. Working on confirming another couple. I'll announce those when they're officially confirmed. So it looks like, John, your screen is shared. So enough for me. Your 10 minutes begins when you're ready.
All right, so tonight as we discuss the origins of humanity and, from my perspective, intelligent design, it is my intention to showcase that intelligent design is not only the most plausible conclusion for our existence, it is also the most logical explanation for the existence of all life as we know it. As people have heard before, I call Darwinism, the Darwinian evolution through natural selection, the greatest scam on earth for a very important reason. As we progress through the evidence against this being a logical, plausible, and probable explanation for our existence, the level to which philosophers and academic elites use it to dismiss a higher intelligence will become clear. Now, obviously, this debate will go in many directions, but before we even get to the fallacies of Darwinism, we must first address what I argue makes the entire premise of evolution fruit of a poison tree, and that is abiogenesis. My opponent will likely argue that, it was a much simpler back then than what we view as life now. And she may even attempt to explain the improbabilities away by saying life exists, therefore the probability is actually 1. However, let us consider if that position of potential explanation for the prerequisites needed for the theory she stakes her life on is remotely plausible to occur in an undirected manner, or if in order for the probability to be 1, the rational conclusion is an intelligent agent. So even if simpler parts somehow came into existence, this does not circumvent the requirement for a minimum number of these parts to all exist at the same time in the same specific location. And while atheists, origin of life researchers try to avoid this conundrum, it is just not that unavoidable. So let us now consider what is recognized as the simplest form of life and how its simpleness by comparison to other forms of life does not mean it is actually simple. The simplest known organism, the Mycoplasma genitalium, has a genome of 580,000 base pairs. This astonishing number enables it to contain 470 genes that code for 470 proteins, with an average of 347 amino acids per protein. The odds against just one specified protein of that length are 1 in 10 to the 450th power. If we calculate the entire proteome, then the odds are actually 1 in 20 to the 164,090th power. And this is without accounting for the increased improbability when you consider that nature had to select only the left-handed amino acids and bifunctional ones. All of this is before considering all of the genes must have also been in existence at the same time in the same location on a chaotic prebiotic Earth in an environment that is admitted to be less advantageous for the required chemical reactions to occur. So now let's put this in context. The total number of seconds to work with in the entire history of the universe is only 10 to the 18th power. The total number of particles in the entire universe, not just here on Earth, is 10 to the 80th power. And the total number of interactions by those particles in the history of the universe is 10 to the 143rd power. Now, all of this is before considering the origin of the genetic code, the assignment of arbitrary values to codons to equal amino acids, and the requirement of DNA and transcription proteins and translation proteins to exist simultaneously, even for basic replication to occur. What is ironic about this is that I am barely scratching the surface regarding the incredible number of variables which must operate in unison for life to exist. So as you're considering all of these pieces of evidence, ask yourself, is it more reasonable to conclude that an external intelligent agent was needed for life to exist, or to imagine something that is obviously impossible to have occurred by chance somehow did occur by chance? We are surrounded by things which have similar improbabilities to occur through chance, such as the technology enabling us to have this debate. Yet we readily accept that the barrier can easily be overcome by an intelligent agent. Now, what would be impossible by any other standard is now 100% plausible and possible. Now, in regards to our technologies, information theory and computer science are fundamental requirements in order for any of this to be possible. Yet, even though the exact same systems are required in biology, the root requirements for their origin in any other context are ignored. So let's now consider the DNA enigma. It fulfills all the parameters of a code. It has arbitrary values, has a code table, it has translation, which equals arbitrary values, codons equaling amino acids. The codons are translated by ribosomes. Codons do not become amino acids. Codons do not chemically interact with the amino acids. It also fulfills the parameters of programming. Input, output, loop controls, codons, syntax, space and time expression, semantics, controlled variable outcomes, pragmatics, if then else function. It's even been determined to be Turing complete. So when you really start to think about this, you come to the The logical argument. So therefore, if information is immaterial and non-random information requires an intelligent agent, then intelligent agents are required for all controlled process instruction. If non-random functional information requires a mind, and DNA genetic code contains non-random functional information, then a mind was required for genetic code to exist. If codes require intelligence to assign arbitrary values, and decoding requires equal arbitrarily assigned values, and the genetic code is encoded, transferred, and decoded, and genetic expression requires translation of arbitrary values, then the logical conclusion is a mind was required for the genetic code to exist. If time-based controls, which we'll cover later, are required for code execution and are executed by separate functions, and they modify outcomes based on temporal variables, and they require simultaneous execution, then foreknowledge of the outcome is required. If programming requires if, then, else logic rules, and syntax, semantics, and pragmatics are required for its execution, and biological cells contain all of these and the tools for its execution, and if no other programming would happen by undirected process, then an intelligent agent is required for the initial programming. Therefore, if in any other context it is accepted that non-random information, coding, decoding, programming, time-based controls, and nanomachines require intelligent agents to exist, and if life requires all of these to exist, and all observed organisms do, then an intelligent agent, and therefore, in my opinion, God, is the logical conclusion for our existence. Now, I must next address neo-Darwinism directly. And here are 5 positions which challenge the premise of undirected evolution through natural selection being a logical, plausible, or probable conclusion for our existence. First, adaptation of existing functions to account for environmental condition variance is primarily executed through epigenetic factors which do not result in new core functions. This is a known fact, and the epigenome is a fundamental element which has shaken the entire premise of evolution to its core. Not only are these adaptations the result of variable gene expression caused by epigenetics, they are not the result of mutations. Rather, are controlled modifications executed through read, write, and erase nanomachines. Second, it is my position that macroevolution is not proven by speciation, nor by variance within species. While Darwinists attempt to explain this with very slow changes over time, it is now known that literally thousands of genes and gene regulatory networks working in synchronicity are required for new body plans to exist. Not only must they work in unison, it has been shown extremely minor modifications are fatal in embryo development. While I do not discount that variations can occur on a contained level, it is my strong contingency that these are the result of reorganization and adaptation of existing data and functional capacity, not the creation of new information or functions solely through random mutations and natural selection.
You've got 2 minutes, John. 2 minutes.
Almost done. Third, the variation of transcription factors and gene regulatory networks results in significant difference in gene expression. To date, the most studied of these are in relation to cognitive function and show 9 to 23% of variation between chimps and humans, for example. It has been shown these differences must work in unison, and any degradation of this, even to the level of point mutation, results in dramatic impairment or death. Not only does this showcase the extreme importance of gene regulation, it also decimates the relevance of similar coding gene sequences in relation to final outcome. Moreover, the significant differences in non-coding regions of the genome become apparent for things ranging from introns, retrotransposons, enhancers, and promoters, to name a few, almost all of which have been dismissed by those against intelligent design. However, the discoveries made in the last decade have now made their relevance unavoidable. Fourth, it has now become apparent through structural biology that not only is the prescriptive sequence information housed in the genetic code required, it must also be geographically coordinated through dynamic real-time folding to enable full gene expression. This applies to interchromosomal data transfer and gene regulation, which not only forces acceptance of physical gene locations to be vital, it also decimates the relevance of similar sequences existing in other organisms. I'm going to skip 5 and go straight to the conclusion. If I asked you for the source requirement for any piece of technology that contains coding, logic gates, programming, nanomachines, and exhibits temporal controls which defy simple cause and effect outcomes, before even accounting for the physical structures required for the execution being in a specific place at a specific time, yet insisted they'd all come into being without an intelligent agent being required, would you think I was exhibiting rational thought or could even be taken seriously? Therefore, it is my position that the existence of life by undirected physical process, without the action of intelligent agent, is not only neither logical, plausible, or probable, but impossible. As you consider these arguments and the expansion of them throughout the debate, ask yourself this: whose position is more rational? Is it those who conclude it is a more logical, plausible, and probable conclusion that these things could not occur by chance? Or those who argue, no matter how counterintuitive it is, you must believe this could all happen without an intelligent agent being required?
Awesome. Thanks so much, John. Just in the nick of time. So thanks for the presentation. Clear, concise. And
I thought I had 12 minutes.
Oh, sorry about that. Yeah, sometimes it's easy to mix it up because there's like debates usually are like 7, 10, or 12. It's always one of those three. Hard to remember which one it's going to be.
It's tough. But Erica, whenever you're ready.
All right. Whenever you want to share my screen, by all means do it, because I've got my PowerPoint pulled up.
Praise. Whenever you're ready, we can share Erica's screen. And good job to the audience for telling Salvador. Oh, sorry. Go ahead.
It says I'm sharing the screen. There we go. Okay, cool. Okay.
Perfect.
Let's see. Can everyone see that? That looks kind of wild right there. What if I go like this? Is that better?
Looks good. Yeah, looks good.
All right, hold on. Let me get this on big boy mode. There we go. Okay, that should look pretty good for everyone out there. Yeah?
Looks good from my side.
I'm just trying to get the checks before I start. Okay. All right. So I'm going to begin now. So my name is Erica, as we went over previously, and today we're discussing intelligent design versus abiogenesis and evolution, which of course the latter I maintain to be the most parsimonious explanation for life on Earth and its myriad of forms today. So what case am I here to make for you? My case is that life and modern biodiversity is best explained by abiogenesis, that is to say, life from chemical evolution, and subsequently biological evolution by natural selection. What I am not trying to say is that this event and the mechanisms that followed were necessarily brought about by chance alone. I have nothing against that. It is very possible, or at least certainly possible in general, that something or someone spurred abiogenesis or implemented evolution as a mechanism, but I don't know what that would look like, and I don't think that we have anything to support that this is certainly or even probably the case as of now. Which is why I am going with the parsimonious explanation, as parsimony is key to science. So the data that we currently have suggests that life arose 3.8 to 4.2 billion years ago under the conditions of primordial Archean Earth. Data from every conceivable field confirms that life, once present, underwent evolution by natural selection over a vast amount of time to produce the myriad of forms that we see today. Now, while I would rather and typically do discuss the latter, I feel today we're likely going to be spending more time on the former, that is to say, abiogenesis and the constraints of it. By contrast, intelligent design under a YEC context argues that living organisms were created more or less in their present form by some sort of intelligent designer. That being said, intelligent design from a young Earth creationist perspective cannot denote creative kinds, nor can they grapple with the overwhelming evidence from an ancient Earth and universe via geology and physics. Intelligent designers also cannot clarify what makes a design a design. This means, most importantly of all, intelligent design lacks any semblance of a model or testable predictions and relies almost entirely on attempting to poke holes in evolution. As such, it has an abysmal literature base, as anyone who is given dipped a toe into the ID community would know. So what is design? Well, design is somewhat subjective. Here we have our Gibbon that says, what intelligent designs? It's incredible that humans did this. It's easy to project the idea of design onto nature. The eye is so complicated, it simply must have been designed, as humans can't necessarily make an eye. But perhaps we shouldn't be placing design upon things that maybe the design doesn't belong, as natural formations may look designed, but they were indeed crafted by nature and time. I don't think anyone in the audience would look at this beautiful arch or the Giant's Causeway and suggest that someone went out there with a hammer and chisel and made them, even though we do use arches and indeed various hexagonal and octagonal shapes in our building. Some things look designed and weren't made by humans, and humans can't make them today at all. So a mountain and a river valley. The mountain allows the river to flow and feeds a growing ecosystem in the valley. But the mountain was not intelligently designed or placed there, nor was the river, and nor was the complex ecosystem that depends on both. They were formed by nature and time. So what about life and what about genetics? So DNA, I do not holds to a coding language. And I've asked my fiance, who is a programmer, he kind of agrees with me on this. Of course, that's anecdotal. But upon a brief look on Google, you'll find that very few individuals sort of equate them as a 1-1 correlation. This is because code does not self-replicate and there is no natural selection acting upon it. But additionally, and perhaps more importantly, the genetic composition of living things is rife with redundancy. This redundancy is not typically functional and thus does not on the whole represent a fail-safe that has been designed. It's also very random. So how do we get life then? How would I propose that we get our nucleic acids, our proteins, and our lipids? Well, getting lipids, which of course are vital for abiogenesis, they essentially self-assemble into spheres thanks to their hydrophobic and hydrophilic nature. But they tend to destabilize in the presence of salt ions, which is why for a while people were like, hey, how are we going to get lipids? The salt in the ocean is going to prevent this even in prebiotic Earth. But lipids can actually form when carbon monoxide and hydrogen are heated and exposed to various minerals, which are typically found in the Earth's crust. We also now know that amino acids stabilize their membranes. So as seen in this paper, which goes much more in depth from 2019, we now have a mechanism, a plausible mechanism that is, for lipids. What about proteins? Well, in a similar way, we need proteins for abiogenesis. And to make a protein, a cell must put a chain of amino acids together in just the right order. But in 2019, it was found that the protein amyloid, which is abundant in nature, can self-replicate in the presence of carbonyl sulfide. Short peptide sequences shaped like amyloids do have what it takes to speed up the generation of smaller amino acid sequences. So now we have proteins. This is from a paper titled The Prebiotic Template-Directed Peptide Synthesis Based on Amyloids from 2018. What about RNA? We have a sort of plausible mechanism for the previous two. What about this one? It's also vital for abiogenesis, and it's composed of nucleobases and a ribose phosphate backbone. In both 2009 and 2017, respectively, researchers found that RNA can self-assemble in the presence of clays and a wet-dry cycle. So this is a plausible mechanism for RNA. To be very clear, I'm not saying that this is what happened. I'm saying these are plausible mechanisms. The physics behind chemical evolution is also well supported. We have two papers here, one which argued mathematically that the molecules in the presence of an outside energy source may reorganize to dissipate heat easier. This sees potential termination in organisms which dissipate heat incredibly efficiently. Essentially, we're seeing the emergence of life as a means to entropy. We also have a secondary paper that suggested that RNA and DNA are the most efficient of all molecules when it comes to absorbing UV rays, which would again help in the procession towards entropy. John likes to appeal to statistics, but do they support him? I have a cartoon here that says no, and I think Bugs is right on this. The problems with creationist statistics are numerous. First of all, and I'm glad that John presented a stat in the beginning that we can kind of go off here, but first of all, they tend to calculate the probability of the formation of modern proteins and bacteriums with all their modern facets, and they do so by appealing to random events. They also neglect the consideration of natural selection. Creationists tend to assume that there's a fixed number of proteins with fixed sequences for each protein that is required for life, and they calculate the probability of sequential trials rather than simultaneous trials. John shrugs this off in some of his videos over on his channel by saying, you know, he kind of, in my opinion, hand waves it as if it's not a big deal that we have these indeed vast amounts of trials and innumerable almost into our modern brains time span, because we know that there are around 4 × 10⁻47 molecules of water in the Earth's current oceans. This means if we had 1 amino acid per million water molecules, we would still have 1 × 10⁻41 amino acids, which have the chance to interact over millions, if not billions of years. They seriously also underestimate the number of functional enzymes and ribozymes present in a group of random sequences. So anytime I see a creationist statistic, I always wonder, all right, well, is it meeting all of the requirements seen here on this list? And the answer to date is no. Conventional science statistics also preclude a young Earth creationist intelligent design perspective. In this first one, we overwhelmingly rejected both species and family separate ancestry with infinitesimal p-values. And in the separate paper, it says a non-evolutionary control model shows no no convergence, and only a small number of parameters are required to account for observations. It is time that researchers insisted that doubters put up testable alternatives to evolution. Because that's the problem here. What I would like to see from John is a model.
You've got 2 minutes, Erica, 2 minutes.
Sorry, you scared me and I hit the button. It spooked me.
Oh, sorry.
No, it's fine. So is abiogenesis plausible? Currently, abiogenesis is the most plausible explanation for the origin of life. We have the mechanisms for each of the major components that make up the most primitive cell. Intelligent design, on the other hand, lacks a model, it lacks support, and it lacks a methodology. It has, through the years, reduced itself to attempting to poke holes in the hypothesis of abiogenesis and the theory of evolution. Speaking of evolution, I hope we talk about that because it's wholly supported by every relevant field in my honest perspective. This is, something that I've given a fairly deep dive into, but I would love to talk about it some more. It's one of my favorite things. So what John must do to convince me and the world of conventional science to which I abide is he must suggest empirical reasons for why the current explanations for the emergence of the components necessary for the most primitive forms of life are inadequate. He also must provide criteria for design as well as a means by which we can tell it apart from non-design. And if he wishes to push the young Earth creationist view found on his channel, he must invalidate radiometric dating, propose a means for delineating the kinds and why humans should be unique from the other apes, cope with the statistics that make separate ancestry veritably impossible, mitigate the heat problem and the various astronomic snafus, and explain the numerous other facets of geology and genetics that preclude a 6,000-year-old Earth. This is what I would personally like to see. I'm sure we're going to get into some good nitty-gritty stuff here. I also would like to tack on to the end of my presentation that I'm not a programmer, nor am I a geneticist. I study mostly macroscopic organisms, but I'm certainly going to do my best. I'll be the first one to tell you if I need some explaining on my end. and that's all I have to say.
Awesome. Thank you. Perfect timing with 3 seconds to spare. So we'll toss that 3 seconds into the much anticipated discussion portion. And thanks for the presentation, Erica. Once again, clear and concise and nice visual. So great presentations to the both of you. Why don't
Try to mix it up, standing. I like to keep it fresh.
I know how much work it takes to make these and put together these presentations. So good job, guys. Yeah, let's jump right into the discussion. I guess since you just finished your opening, Erica, if John, you want to ask the first question, I'll get the clock going.
Yeah, by all means.
Yeah, sure. So, I always find it very fascinating how folks taking your position and so often lead with our computer code isn't self-replicating. To me, that is a just stunningly ignorant position to take. And I'm not really sure how your fiance can reach that conclusion when what we're trying to do with machine learning in programming right now is enabling that exact thing to happen. And obviously that's before you even consider the fact that you can write a backup script that does do a copy. So I mean that whole premise of self-replication has zero to do with whether or not the information requirement is reasonably either created and then initially created or modified through copying. That's just one component of this whole deal. So I'm not really sure how that negates the premise of, and the other point you're making, which I'm leading to, which is it's not a code, it's just an analogy, which is kind of the point you were making, which I can directly counter, but I'd love to understand why you're coming to that conclusion. Yeah,
sure. Well, first of all, my fiance is a programmer, but also I did not show him my presentation. I showed him a previous debate that you had, I believe, with RJ. So he was informing me on the arguments in that conversation, not what's here today. I don't know if he knows about machine learning or not. But more importantly, even if code replicates, which I don't know if it does. If you're saying it does, I'll take your word for it. But I I'm
saying it can. That whole replication portion is like not a valid piece of like how does it self-replicates, therefore it's not like code in terms of the requirements.
That's a core tenet of any kind of mutation, any kind of evolution. It requires replication because it is during the replication process that change takes hold. So if your code isn't replicating, it's not subject to change and it's not subject to selection.
No, I understand that. The point I'm making is that to say that the requirements in the whole self-replication portion has zero to do with how they those things I just mentioned originated.
I would very much disagree. I mean, from a conventional, maybe from your perspective, but from the perspective of conventional science, without replication, you're not getting change ever, and that includes the emergence of replication mechanisms.
No, you're missing the point in terms of the.
Elucidate me. Explain it like you're talking to a fifth grader.
Okay.
I'm not a programmer.
So you are operating from the position that the genetic code does not fulfill the requirements of a code, correct?
Yes.
Okay. So what are the requirements to be in information theory to be considered a code?
I have no idea what the requirements are to be considered a facet of information theory. But the problem is, if you're trying to make an analogy,
I'm not making an analogy. I'm making a direct comparison. Is the point that I'm making? You are making the point that it's only an analogy,
right? But John, it can't be.
I am saying it's the exact opposite.
You don't have replication and mutation. That's just a fact of biology.
No.
Important.
No, you're missing the point in terms of the root origin of the code that now self-replicates. The root origin requires.
So the mechanism is what you're speaking about. The mechanism.
No, I'm talking about the organizational structure of how the information is contained that is now you're claiming is being modified through self-replication. In context of abiogenesis, one of the requirements is that arbitrary values must be assigned to a codon to equal an amino acid. There's no way around this.
Suggesting they're arbitrary values. They're no more arbitrary than any value for atomic number is for any element. They're laws of chemistry. That's why it's called
no. You're missing the point. This is why I made it in my opening statement. I made the clear delineation, and this is why there's been many papers written on this of why it's the DNA enigma. I use that term from a paper from a atheist origin of life researcher. Because the arbitrary value assignment means it's arbitrary because the nucleotide base pair sequences of codon do not become the amino acid. They are symbolic representations of the amino acid. There is no chemical interaction between the codon and the amino acid. It requires the translation mechanism, which is the ribosome. There is no way around this. This is like there's papers written on this whole conundrum of like this is the single biggest question about origin of life is how could this have possibly occurred?
I don't know about that. I spent the past couple of days kind of digging through abio papers, and there didn't seem to be like the attitude that you're presenting here is that it's like, oh gosh, sheesh, we're stumped. It's just not, that's just not the reality of it. But with regard to what you're actually saying, I mean, you can laugh, but it isn't. I mean, it just isn't. I would encourage everyone out there to go check it out for yourself. Do not take my word for it. Go look and see what's actually being said. And to me, I mean, it sounds like you're dealing with a lot of vagary here. You're basically
no, actually, I'm being very hyper specific.
No, I don't know about that because you're essentially from what I'm picking up. It sounds like you're essentially saying, where do we get the rules of replication from?
No. I'm saying, where do we get the rules for the information that is now replicated? That's
what would you classify as an information, though, John? What is an information?
Okay, so in this context, what we're talking about representative code base, symbolic code base of the syntax of the genetic code. This codon equals this amino acid.
Yes, so you're asking for why do things pair the way they pair, essentially.
Okay, do you understand that, like, the whole premise of semantics?
Well, yeah, I understand it.
Okay, and so it's semantic, right? And the same logic applies to the genetic code. There is semantics and pragmatics that are derived from the syntax of the genetic code.
I don't argue that there are semantics or pragmatics.
Okay, so the semantics is immaterial meaning of the codon. How does the immaterial meaning get applied to this that is now being translated? There is no other code on the planet where anybody would argue that those translational values could ever be initiated and assigned without an intelligent agent. There's no other concept.
Why not?
Okay. So does the letter
explain to me what the problems of that are? I mean, you understand, like, from a perspective. Before you answer, I want to quantify myself so that you know precisely what are now that are capable of dealing in semantics and in pragmatics. Vervet monkeys are capable of picking up new linguistic words, so to speak, from one another and applying and altering the meaning to them. Are the
monkeys already fully formed life forms with intelligence?
I mean, it would depend on what you define intelligence as. I would call them fully formed life.
Do they have the ability to do information processing?
I would say to a degree they do, yes.
Okay, so literally everything on a cellular level is information processing. This is a well-established premise. Your brain, every single brain from the simplest brain of the lowest light form to us, is doing information processing.
No, it's not. It's not though. It's not information processing. It's response stimulus.
No,
you want to refer to
okay, Erica. This is literally. There's conferences on this whole thing of the information processing in biological systems.
How many of those conferences have you been to?
I've watched quite a few of them on YouTube. They're freely available on YouTube, and this is also discussed in.
So you watched them all then. All right. Deal. I would love to have a conversation.
So hang on. Earlier you talked about redundancy, right?
Yes,
but somehow it's a negative. Somehow it's a negative.
I would very much appreciate not being condescended to. I don't want to waste my time in a conversation where I'm being condescended to.
Well, you've kind of approached it from that whole perspective.
No, I have yet to have a single person complain about my discussion style, and you just seem quite angry. I don't know why. I would love to have a.
Actually, I'm actually not angry. I'm cracking up at somebody who's done as much research as you hasn't come across the things that I'm talking about, and then is making jokes about me not having attended a conference. I've only watched the conference. I say that's condescending in and of itself.
No, it's merely a response to the vibe that I'm picking up, but I'm keeping things cool on my end. I just am a simple request.
Okay, so you mentioned redundancy as supposedly being a negative, correct?
Absolutely. No. Let me rephrase that. I didn't, because I don't believe I said it was a negative. I believe I said it was indicative of non-design.
Okay. Well,
in the context of genetics.
Okay, so. Redundancy, there's actually been papers written on this in the context of how the redundancy of the genetic code is what actually enables translational pausing, which is a vital component to protein synthesis and actually houses a subset syntax which enables dual control, temporal control of the ribosome. And it's even been, analyzed from the perspective of does it qualify as a computer language? Yes. Machine code? Yes. It's a hexanucleotide code base. I mean, there's it's been mapped out.
Yeah, redundancy is a great thing. And sometimes it protects a cell from certain bad things from happening, but other times it's not present when it should be or where it would.
You're missing the point on the design factor. Okay. So we have a top level code base, which is the code on assignment for the genetic code in general. Then built in synchronicity from the same code base, you have a secondary syntax, which is now controlling the actual execution of from a temporal factor of the ribosome for protein synthesis.
Yeah, sure.
Okay, so you're suggesting that if you're saying that this is not indicative of design.
No, I'm saying redundancy from the most minute cellular mechanisms all the way up to in looking at entire genomes. We have repeats in completely random places. We should, if
okay.
Design, right? As a designer, I think we could both agree, or at least most designers would agree. I'm not a designer, so I guess I can't weigh in on that. But the hallmark of design is simplicity rather, and efficiency. That's not what we see in the genetic code, and that's not what we see in pretty much any whole genome you can imagine.
So that's not what we're starting to realize in the context of structural biology.
I don't think that's true, because I've looked at papers.
Okay, well let me finish my point.
In the past.
Let me finish my point, because this is relatively recent stuff that's starting to come to the forefront. So things like the duplicate regions that are supposedly these examples of totally, redundant
location.
I'm saying throughout the genome. Okay. So in the context of data transfer and function, we'll use a top level example of a content delivery network, CDN, in the internet, right? So every major web host, Google, everybody, they've got multiple gene server locations spread throughout the globe.
Gotcha.
And you have multiple copies of the same, if you're using a CDN network, you have multiple copies of the exact same program on different servers in different geographic locations around the planet, so that loading time can be accelerated versus going to a singular source. Sure. The same logic applies to genetics, because the exact same genome is in every cell, obviously, except for the egg and sperm, obviously.
Right,
but
right.
the not every cell type is using every portion of the genome. So in different cells, different portions of the overall genome are exposed, if you will.
Sure.
So if you don't have the most top, highly used components that are easily accessible from various physical locales, then you're actually slowing down you have to unwrap the histones of another portion of it to go get that specific gene.
Right. I think I get what you're saying.
So to say that those pieces, I'm just talking about there's multiple layers to this, but just that from a top level portion.
Yeah, I think I get
to just count that is like saying that it's less efficient to have a content delivery network for your web app than having a simple or only having one server when there needs to be access from multiple points.
I get what you're saying, but that's the problem is, and I would agree with you if that's what we saw, but it's not. We have entire portions of the genome, and Standing and I have had this conversation previously, but like when you look at the functionality of the human genome and the functionality of other primate genomes, there are enormous, massive portions that, to our current knowledge, just don't do anything. And because of that, that's what I'm meaning when I'm saying, I'm meaning this from a surface level, because again, I'm not a geneticist. So I'm meaning it from a surface level of redundancy, where it's like we see these same, sometimes they're telomeric, but we see these same repeats over and over and over again. They have zero impact on phenotype. They're simply redundant. And what I'm saying is, all right, if you're a designer, right, that's probably not going to be the game plan, right? If you've got like a river and this river tends to overflow, you might build like dikes or sort of flood ponds or whatever, little reserves to catch the water as the river overflows so that it doesn't damage anything. But in genetics, instead of seeing like one or two in the areas where it might swell the most and overflow and flood the local region, you might have repeats for 6 miles in one area, just dike after dike after dike after dike all the way back, and then zero in another area where it floods all the time. So I'm talking about this weird redundancy that makes no sense to me from a design standpoint.
Let me address that.
Yeah,
so
go ahead.
There's multiple aspects of that. So one, say we don't know what it is, therefore it must be useless. I mean, that foundational premise is being eviscerated on a daily basis, especially in medical research, less on the Evo-Devo side, but much more in the medical research side.
Second, functional.
Sorry, what?
I said the fact remains, like based off of a paper literally in like 2017, it's still like the functional portion of the human genome is maxing out every time at 12 to 13%. And yes, you're right. They're finding new functions all the time. I do agree with you on that. The problem is the level of functionality for what they're finding is getting smaller and smaller and smaller exponentially. So we might find something new that a new gene does, or an ERV, or whatever.
What they're discovering, they're not just finding as many coding functions. What they are finding is the regulatory components that are altering and are controlling the outcomes, and that is expanding dramatically. Basically, pretty much every medical discovery has showed, oh wait, this thing that we were told wasn't functional, even a point mutation in it causes X genetic disorder. But where I'm going with all this is things like tandem repeats, short tandem repeats and such, that are viewed as, oh, what is up with this? Just repeat. It's the same thing, has no function. What are they finding out now from a structural biology perspective? They're actually discovering that in terms of the DNA folding components that are actions that are required for gene regulation, that those short tandem repeats, which have been being told have no function, actually serve as literal engineering components that act like springs almost to enable the folding process for gene regulation.
Right, but
and they are also discovering that even point mutations to those short tandem repeats, which up until very recently, like the last 2.5, 3 years, have been considered complete junk. Actually, those point mutations, even in short tandem repeats, which have no function, quote unquote, are directly inhibiting the ability of gene regulation.
Right. So the thing is again, I have no problem with them finding that new things are doing new things, like new aspects of the genome are engaging in, helping with the transcription or what have you. I don't have a problem with that. But what I think you're missing here, and what I would wager if you went back and looked at those papers, is that the impact on phenotype is impeccably minute. And all geneticists agree, at least the ones that I've read about and in undergrad and indeed in my master's, is that for something to be functional, it must impact the phenotype. So if you went back and looked at it, I bet it would be quite small, because I would be very surprised if in the past, let's say 2 years since Grar's paper came out, that they were coming out with an entire chunk of 25 to 50% functionality for the genome. And that's my point. It's not that we're not finding solutions for itty bitty tandem repeats, or maybe this section that we thought was junk actually turns out to do something. It's that the entire trend is redundancy, and the entire trend seems non-designed.
No, the trend with like the 4D genome project and other things of that are showing that there is massive, we're actually trending in the complete opposite direction of what you're talking about. I mean, and talking about phenotypes, for example, I mean, there's quite a few papers on the incongruency of phylogenetics and other things that are being used. But where I'm going with all this in terms of phenotypes and morphology is they're now realizing that things like microRNAs have massive implications in terms of body plans. Yet from the papers, it's literally saying, oh, these completely random, hyper-specific, but the outcome being hyper-specific microRNAs, oh, these may be the explanation for the Cambrian explosion and all of these new body plans just popped into existence. So the point I'm making is that we're looking at things that supposedly had no bearing. Now we're finding out that very hyper-specific things that we are currently being argued to be completely random are now the result or causing the new body plan outcomes of evolutionary theory.
I wouldn't be surprised if that's what they were finding, but again, that's not my point. I would
that's not what they're
100% correct that they're finding out that new microRNAs, new aspects of epigenetics, whatever, they're showing us how certain changes can come about. In fact, if were I more well versed in genetics, I'm sure I would find them very interesting.
Right. Here's the point that I'm trying to make here, though, is that.
Hold on, let me just finish. I was just going to say that it has to do with whole genome, and it has to do with what trend are we seeing. And there's no paper that I've seen, and again, because Standing and I have had this conversation several times, I stay up to date on that. There's nothing since 2017, or might have been 2018, with Gar et al. Coming out on the functionality, the as a whole functionality, which is my point here, of the human genome. It's staying very low. And while they find new traits, they do smaller and smaller things and make up smaller and smaller portions of the genome, i.e. redundancy.
Okay, I think you've missed a huge portion of my points here, but
explain it to me then. If I'm missing it, I want to know. I want to get your point.
What I'm saying is that what we are discovering with things like inter and intra chromosomal gene regulation is that the temporal factors and the physical location of genes is extraordinarily important, which directly indicates the foreknowledge temporal values execution that had to be in account before these new things could occur. So you're having to, the entire point of evolution is that there is no foreknowledge required, and it's all the result of natural selection. Mutation, sure. Natural selection, right?
Sure.
Okay, so your model has to explain how something that has to be in place before the other thing happens, right? From a time factor.
Yeah.
How that came into existence without it being predetermined.
So are you aware of precursor mutations? They're essentially the concept that it's like if you need A, B, and C to do something, typically A and B are going to be relatively silent in phenotypic expression, and then you have both of them and you're just trying out the genome.
You're thinking about this from a linear.
It happens.
So you're thinking about this from a linear perspective. This is having to occur from both a 3D and a 4D perspective. The linear changes that you're talking about inside of a sequence are not even, we're not even talking in the same stratosphere.
I'm not talking about that. I'm talking about, like, for instance, the classic is like Behe or Meyer with the flagella, the irreducibly complex flagella. You need all 5 parts for it to work. And if all 5 parts don't happen simultaneously, you have something that's rather useless. But what multiple, including, I want to say it was Francis Collins, but I don't think it was actually him. But work on the flagella, and I could get you some papers if you'd like.
I'm aware. Ken Miller is the person you're referring to. I'm aware.
Yeah,
I'm aware of the whole
Miller,
argument of it not irreducible complexity and stuff. That's not what I'm talking about.
No, you're talking about irreducible complexity on the scale of mechanism, are you not?
I'm talking about it in both the information sequence requirement, the temporal value assignment, the geographic spatiotemporal location.
Yeah, so time, where it is on the planet, things
No, I'm talking about right now. I'm talking about inside of the genome.
Okay.
So
yeah, you're right. We were on different pages on that.
The cascade problems of frame shift readings are catastrophic in almost every instance, right? And what is being realized in the context of structural biology, specifically in this context, what I'm talking about right now, of the interchromosomal gene regulation and inter and intra chromosomal gene regulation, is that the introns, the exons, the promoter region, all of those things have to be in a specific geographic location, even if the sequence that's actually being executed is not in a linear connection to those factors.
So I don't understand why you have a problem with the solution that numerous biochemists and sort of geneticists are proposing, which is a sort of stepwise and precursor mutation filled solution. What do you think, that those just don't happen, or do you just not find that compelling, or what? Why don't you like that solution?
The correct order inside of the sequence. They have to be done inside the sequence in the correct order, right?
Right. Yes.
There has to be no modification. Okay, so we've got base pairs 1 through 10 are in the correct order. Then as 10 through 20 are forming, number 2 changes. So we're going to say the first 10, even though there's no known function at this point that's being conserved through natural selection, somehow the first 10 say perfect until we reach the other 300 that are required before it's a functional protein. So one, just from an improbability perspective, the math on that is just insane to actually think that results in a new functional protein. But that's before you even account for, not only does all of those have to be correct, in order for that new, supposedly through natural selection, new functional protein that has come into existence from scratch is now only executed through gene regulation factors that have to have also been forming at the same time, or come into existence at the same time in terms of this new protein that's in a different chromosome that has to be folded over physically to bind with the promoter region of this new sequence.
I see where you're coming from.
You're having to say that all of these things are happening.
I get you.
I wasn't on the same page to ultimately reach the end conclusion.
Yeah, I wasn't with you, but I think I am now. I think that, and I'm sure you probably get this a lot with the kind of style of argument that you take with this kind of stuff, but I really do find that it's a bit of an argument from incredulity from some ends. I'm sure you get that a lot. And I don't know the details of this specific type of protein or mechanism that we're discussing. I would have to be probably a master's or PhD student in that to understand the inner mechanisms. But with a lot of this stuff, it's like I mentioned in the slide that I had on my presentation about how creationists kind of cope with statistics. I think a lot of times what tends to be missed, what tends to be lost in the ether, are the relationships between these various parts and how things are selected for. It's like if I had an alphabet of A to Z, right? And it's like I'm spinning a dial on 26 different wheels, and I want them to be alphabetically in order A to Z, and each wheel has all the letters. From a natural selection standpoint, indeed, with things like proteins, which are hyper necessary, and I suggest you take a look at that amyloid folding paper, protein paper that I had on my presentation too, which kind of covers a little bit of what you're saying, I think. But if I spin all those wheels and I get, A in the right place and P in the right place on the first round, according to natural selection, those two get to stay. Like, that's kind of what this is a very simplistic explanation, but for things like things have to be in a specific order at a specific place at a specific time. You're not spinning all the wheels every single time you run the die. Like, the ones that were in place, they get to stay. And furthermore, you've got trillions upon trillions upon trillions of different wheels being spun all around the world, or around the location of, if we're looking at a genome in different places on the genome, each and every time. Through of course your time, whichever time span we're working with. I'm assuming we're kind of going back pretty far here. So to me, I hear that and I'm like, wow, those numbers, they sound pretty impressive. But when you consider the laws that typically govern nature, and from my perspective, from contemporary science, how much time and space we have.
I love it when evolutionists bring up the time and space variable, because number one, per your own evolutionary timeline, you have no greater than 500 million years and potentially as short as 200 million years for the first form of life to exist.
No, 3.8 to 4.1 for the first life form. That's billion with a B.
Years ago that it came into existence, which in terms of the 4.54 billion years from the formation of the Earth per your timeline. When the form of life came into existence, we're talking about a total of 500 to 200 million years per the evolutionary timeline for the first form of life to come into existence.
Oh, from the origin of...
You don't have billions of years to work with for the first form of life to come in. You have no more than 500 million per your own timeline.
You're right.
So the improbabilities of all this and the complexities are not in your favor. Secondarily to all that, the point you make about, oh, it's happening all over the place. Cool. I could care less about that. Because at the end of the day, all of these variables must come into existence, be in existence at the exact same time, in the exact same physical location. It doesn't matter if one of them happened over in Australia geographically.
Sure.
They all have to be, they're molecules, right? They all have to be in the exact same location.
I'm with you, but I want to insert something there, because all of the recent studies that I've seen have RNA world or metabolism first, whichever origin of life you're going with, occurring in very concentrated patches near hydrothermal vents. So the odds of getting, first of all, we're dealing with concentrations way above what we see even today. And there are some excellent papers that from 2018, 2019, very, very recent, sort of expounding upon that I probably can't do here, at least not to do it justice. But so we're not dealing with an entire open ocean of chemicals just sitting and stewing around. We're talking about vastly concentrated with minerals and amino acids areas close to these warm hydrothermal vents, where these trials are going on by the million, by the billion through time. So you were right. My math is not the best. So you were correct on that it's more like 200 million to, I would say, if we're going with a 4.8 billion year old planet, which some are suggesting, you can have up to about 1 billion years. So with all of that in mind, near these concentrated areas makes it more likely for these things to bump into each other. I don't get it, John. I'm not with you. I don't find that incredulous.
Do you not realize that the chirality problem?
John, come on. The chirality problem, that's you got to be. I'm not saying you in particular. I'm just saying I've heard that argument from a lot of creationists. And
chirality problem is a recognized one in origin of life research.
Right now, if you go to, there's a meta-analysis on all of the abio studies that was released in 2015 or 2016, maybe, along those lines. It covers the chirality problem, and it offers up 3 or 4 different solutions, all of which seem, in my opinion, again, not a geneticist and not
so you realize that
highly plausible.
That to overcome many of the issues like the biofunctionality problem, the chirality problem, all that stuff.
I don't know the biofunctionality problem. Explain that to me.
Hang on, let me finish.
Okay.
These things are overcome in all observed life by enzymes which account for these factors, like the polypeptide bond not forming correctly, and you have a 50-50 chance each time that it's going to form a correct peptide bond, and in the amino acids. If they don't, you fail. You have to start again, which is why the improbability factor, which is one of them, is in the fact that the likelihood and it being a plausible conclusion that a protein that's 300 or 400 amino acids long, when literally every bond has to be correct to reach the functional protein. And every single time, this is one of among many, it not only does it have to be the correct amino acid, the bond also has to be formed correctly every single time. And
so
one failure, you have to start again. So your whole aspect of the linear fashion, it has to be correct, all of them incorrect at the same.
I'm with you.
There can be no errors. So you're starting from scratch every single time.
I'm with you.
You made the point of oh, we're by these alkali vents and such, right? Well, from a chemistry perspective, you have to account for the fact that there's different stages from a temperature perspective. You also have to account for the reality that without the protection mechanisms of the cell membranes and things of that nature, as well as other enzymes, both the heat and the sunlight itself would be causing the collapse of these structures on a very accelerated basis. Also, you have the lack of oxygen per the evolutionary timeline, worldview, prebiotic worldview.
Yeah, but the
oxygen. So you're also not being able to block UV radiation, which also accelerates the destruction of these.
Here's the thing, though, John. Because you've said quite a few things, I want to make sure I don't miss any of them. So first of all, I read a paper just this morning in preparation for this debate suggesting that the conditions for life to form in an abiotic fashion from chemical evolution is astronomically more likely when oxygen is low when compared to when oxygen is high, because it turns out oxygen is just kind of a nasty element to deal with when you're a budding, microorganism near a hydrothermal vent. So one, oxygen is not going to be our friend, which is why it certainly is a good thing that according to the rocks, it was very anoxic condition wise. Second, your lipid cell membrane is what's protecting you from the UV radiation, and lipids, as I pointed out in my presentation, have been shown in media res, like in real life, to form naturally near hydrothermal vents. The crazy thing about lipids, as we know, they have a phospholipid bilayer, and they
let me clarify that piece on the lipid point you're making. Which the example you're using is actually the replication of a already existing one. They took I believe it was 42 amino acids in length, that particular lipid you're talking about.
I'm not talking about proteins. I'm talking about lipids. They're just phosphate head and the little tail. They make
I said.
No, it's okay. I get it.
I've read this paper.
Yeah, I've done this before too. I get it.
The self-replication was only occurring from one that already existed in its complete state. It didn't just form and then start replicating. They took one that already existed, dropped it in that environment, and then it began to self-replicate.
I'm not talking about any, like, lipids don't, to my knowledge, self-replicate. Like, I'm talking about lipids, the little guys that form the cell membrane by coiling their tails together and their hydrophobic heads go on the outside. They're not, when I'm talking about these guys appearing near hydrothermal vents, they're not replicating, they're forming. They're found naturally by hydrothermal vents by the heating of carbon monoxide.
Okay, we must be talking about different papers. Because I've read something exactly on this whole thing, and they were talking about how they had to take a one that was formed for this whole thing, to this process.
This is naturally in hydrothermal vents today. Like that, you couldn't go, and I don't think it would be you would not want to get too close to the hydrothermal vent. But this is actually just taking samples from hydrothermal vents and seeing if there's lipids, and then there just are. So that's my point. So already in this natural environment, you're getting an encapsulation that's going to protect you from the UV rays. Check. The second weird thing about lipids is they can only maintain a stable boundary if amino acids, the basis of proteins, are present. Otherwise, they break apart in ionized water, aka salty water. So the fact of the matter is, and we know that amino acids are present near hydrothermal vents because we also find them near hydrothermal vents. So when the two are in the presence of one another, essentially what you get is a lipid membrane that surrounds amino acids, and you've got two of those first steps already there. All you need is RNA, and RNA coincidentally involves itself a lot with nucleobases, and you're going to need amino acids there too. So
hang on. So I see where you're going with this whole deal, but the point you were making earlier about this, we're obviously going with the RNA stuff, is, oh, we've seen it form on clay and such. This, and there's been papers on this whole thing of how cool RNA molecules will form on clay. This has zero relevance to how the syntax, semantics, and pragmatics value assignments happened, and then the components that are required for its transcription. The whole, DNA is this DNA molecule can self-replicate has zero value in relation to it resulting in a protein. I mean, there was a paper written that was published last year about how, hey, we finally have to admit that the RNA world hypothesis by itself is not valid, and we have to have proteins, transcription proteins, in existence at the same time.
But I think that's I think that's, just to intercede quickly, and I'll let you go on again. I think that's a little bit of and I don't mean this in a derogatory way, but a bit of a quote line, because as far as I know, biochemically speaking, most people aren't gung-ho for RNA world right now. It's mostly metabolism first, which is why it would make sense to see in a paper someone being like, RNA world's just not going to cut it, because now we have a better hypothesis. I'm sorry, continue.
I mean, that switches up on a regular basis. It's gone from protein world, RNA world, metabolism world. I mean, it bounces around
as science should.
By like crazy, and all of them keep running into chicken and egg problems. All of them. And okay, hang on. They keep running into chicken and egg problems. This is a well-admitted premise in many of the papers. They keep running it here. Okay, this is why I think this one's the best. Here's all the problems with yours, but ultimately they all run into the same chicken and egg problems. Which at some point, all of these variables have to exist simultaneously in a structured format with value assignments to the different components that can be transcribed, translated, and executed.
For your value assignment thing, and I'm sorry, were you done? I didn't mean to interrupt. Sorry. So, did you say anything else on that?
Yeah, I mean, the point I'm making is unless you are willing to conclude that, for example purposes, in binary, the letter A equals 010001. Okay. Is there any context in which, without a intelligent agent assigning values, could the A ever be equal to 01001?
I think that here, because I heard you talk to speed of sound of gravity on this, and I think we might just have like a fundamental disagreement on, because I'm assuming that from your perspective, the laws of chemistry are also intelligently placed where they are.
No, the laws of chemistry have zero relevance to what the arbitrary value is of the codon to amino acid. For case in point, in human technology, as we speak right now,
sure,
we are using DNA and the chemical process of base pairs and ribosomes and everything to both store and execute information and programming functions. Okay, I don't think there's anybody with half a brain on this planet who would argue that the processes that are being executed through chemical functions and reactions inside of DNA for the information that we're storing in it and the arbitrary value assignments of the syntax that we're using, just because the medium is DNA, does not constitute value assignment.
And I think I'm getting what you're saying, like conceptually speaking, but I guess I just don't understand why value assignment can't be assigned through the trial and error of natural selection and numerous trials along the way. And what works. I mean, I don't understand.
We have start codons, we have stop codons.
Yeah, right. And how does DNA conduct its business though?
If chemically for the execution of it. Okay, so do you agree that a gene sequence and the base pair organization of which it is organized is equal to the required organization of proteins that result in or amino acids which result in a protein?
Yeah, sure.
Okay, so genetic code sequence A equals protein A.
Yeah, I would agree with that. I mean, that's pretty much what we see.
Okay, so in order for that to happen, that has to be a translation mechanism. So you have transcription from DNA into mRNA, a bunch of other stuff that goes on in that process. Then it goes to the ribosome, and then that transcript is translated to equal those proteins. Those proteins are put in the correct order, and now you have protein synthesis. And of course, there's other stuff that happens, chaperones and stuff that happens after the fact. In the context of direct comparison, we have a 3D printer that is executing a program to result in a physical object. And this is why, in the context of like translational pause, and the whole point I was making in what the significance from a design perspective of the dual syntax is that mRNA is acting as both the elements needed and the order and the time of, just like you would do on a 3D printer, of, hey, the aluminum needs to go in this angle, this time, pause, next, and then you're fast forward, you now have a three-dimensional object. That's exactly what's happening in the ribosome.
Well, it's It's not, though. It's similar. I mean, there are comparisons that you can draw. I agree. There are comparisons that we can draw from a human archway to a natural archway too. But for me, the problem that and I realize that's a rudimentary comparison, but to me, I just don't understand what is difficult to kind of not conceive, accept would be the word that I'm looking for.
Okay, so let me
finish my point. So when we look at DNA, how does DNA conduct its business? It does so chemically. Yes, there is a spurring, there are instructions, so to speak, and I use that term colloquially, but when it gets right down to it, DNA responds to chemistry. That's why we can impact it chemically. That's why it can mutate under the influence of radiation, which can cause various changes and whatever in the genome. But my point is that it's all right, if DNA currently conducts its business through chemistry and physics, why is it so hard to conceive that initially this was also what happened under the sort of guidance? I realize that's anthropomorphizing it of natural selection. So what works sticks around, and what doesn't, well, the process up until that point collapses. You're right. You have to have a lot of things in order. In order for something to
let me directly address your point there. So I think you missed it because I've already addressed this whole chemistry is not relevant to the medium and the process. It's not relevant to information.
I get what you're saying. I just don't.
So the point I'd like a direct answer from you on this. So the first thing that was stored, one of the first things that was stored in human usage of DNA for information storage was a picture of a horse, crossing a finish line. Do you think it is remotely plausible that given an infinite amount of time, an infinite number of universes, and an infinite number of chances, that somehow the data in the correct order of genetic syntax and nucleotide order could ever result in being able to be read as a picture of a horse?
If you're selecting every time one gets it right, then yes. Why wouldn't it? With infinite time, especially. I mean, from my perspective, it's I don't understand why. I feel like we're going back and forth. I'm saying yes with selection, and you say, but how's it all going to happen at once?
No. Okay. So first, you have to account for the data, but you have to account for the syntax that can be read to equal the correct first point of the picture of the horse.
Right, but why can't that syntax come about naturally? Do you think that for every organism,
again,
from the littlest ants to the termites to the vervet monkeys to the geladas, whatever, every organism that communicates with one another wasn't taught syntax. They understand things by chemistry and by vocalization. So I don't understand, and the reason partially
how are they able to do so? They have the ability for information processing, which you're claiming doesn't exist, but is exists in every single form of life.
John, I'm saying that information processing is not necessarily, nor does it actually, I wouldn't even say is not necessarily, I would say just strictly does not need an intelligent input. It's response stimulus, it's selection, and this is my thought. I'm agnostic. If you want to sit here and tell me that God spurred life, sure. Then I'm going to say, what the conversation I would love to have with you in particular is more to do with what you think after life started, but it's the whole fruit of the poison tree. I get it. You want to have this, we want to have this conversation too. I think it's an important one to have, but I just don't buy it. I don't think that it's that incredulous.
Okay, here's what I'm just really not comprehending is you think it's natural that if the genetic code and AUG equals start, right?
Sure.
That is a completely subjective and arbitrary meaning that has to now be interpreted. There's no way around this. Okay. So you're claiming, this could just happen naturally. Okay. Is there any scenario in which you think that without an intelligent agent applying the value that the letter A being equal to 010001 in binary could ever occur naturally?
Again, I feel like, and I'm understanding where you're going. I think that we're reaching a fundamental level of what do we accept?
Do you think that could ever happen through a natural process without an intelligent agent? That's a yes.
Again, I mean, you've asked me this before. I think if we have selection as a player in the game, and again, I think that we do.
You don't have selection yet. You don't have selection
yet. Why would you not?
Because,
it doesn't do anything. It doesn't do anything. If it does, it's automatically selected for. That's the most basal level of simple evolution.
Okay, so We're talking about how do you get to the point of even to be able to have natural selection?
Right.
Right. So if you don't have this process yet, and in order to get to the process, you have to have this as a predecessor. You have to have a start in protein synthesis. If the stop and start codons are not in the correct spot, the protein does not form. That is a fact, right? There is different start and stop codons in different types of organisms. Unless you have those factors along with the codons which equal the specific amino acids that are going to be done, you will never get a protein being formed. Period. There's no way around this.
So your barrier to it is the fact that there are seemingly arbitrary, and I'm saying seemingly just because, again, this isn't my area. Maybe they are arbitrary. I don't know. But you're saying that these seemingly arbitrary values have appeared and they obviously caused something to happen, since there's no conceivable way to understand why it is that they're interacting with one another. Someone must have done it. Am I gathering that correctly?
I am suggesting that ultimately,
like in a simplified version, though.
Ultimately, yes. But I'm suggesting that when you have arbitrarily assigned values, which must be the result of sequential codons and nucleotide base pair sequences, and a ribosome that is able to interpret them as the appropriate amino acid, and you have to have the tRNAs already in existence, and you have to have all these other proteins for transcription. That's just not remotely plausible that all those things could ultimately be derived without a external agent. But in the context of the DNA portion, RNA portion, all that stuff, when you actually look at it from a chemistry perspective, there is no chemical bond between the base pair nucleotides, in between the pairs. There's a hydrogen bond between the two bases, and there's a bond to the phosphate backbone of the double helix. There is no chemical bond between the base pairs. So you have an entirely random. There is no chemical reason for those base pairs to organize in a specific sequence. There is none.
So essentially,
you're dealing with 100% randomness. You're dealing with 100% randomness in order for the sequence, the DNA to somehow end up in the correct sequences before you even account for the process by which the start and stop codon and the amino acid codons are now delineated.
Right. So the rules
you get to the factors that are required for it.
Yes, I'm kind of gathering what getting what you're saying.
So where I'm going with this is you are coming at this from the perspective that somehow through random chance, all of these variables, we're talking about hundreds of thousands of them that must be in the correct order without flaw in order for life to exist. And there could have been if you've got these certain portion correct, oh wait, they all stay, even though we're not to natural selection yet. I have to get to thousands and thousands of thousands of things all in the correct order for somehow the spontaneous generation of the proteins that are now going to be able to transcribe this and translate this into functional proteins to now expand the process. And the point I'm making is when you start to really dive down into things like, as the example I made in my opening statement, for the recognized simplest form of life, you need 580,000 nucleotide base pairs in the correct order. That's from a secular paper. That's not. But
John, you're using an extant organism there. I mean, every paper that I've ever read in regard to abiogenesis, though, has spoken on the fact that the most basal organism, the very first thing that would have appeared under this lens, and I want to touch on some of the stuff you just said in a minute, but this one was I noticed it in your presentation. It's nothing like anything we have here today. I mean, this organism, hold on, I wrote it down. Mycoplasma genitalium is just as evolved as we are. It's still here. It's still been undergoing selection and change. There's no reason to even posit that the very first organism would have been even as advanced as that. So
they're recognizing this as the minimum requirement.
No, this would not be the minimum.
No. They're postulating on some of these proteomes that they're are not the equivalent. The point I'm making.
We're postulating it to a point, though. Like we're postulating it to the point that it's like, if we had one, there are billions of, or rather millions, 2 billions of organisms alive today. Therefore, the bare minimum for the first life must have been, at least some rather large fraction of that. It's like the origin of life is something that I will readily.
So pretty much everybody agrees that you have to have a helicase.
No, I'm with you. I'm just saying.
Okay. So do you understand how big
organism when it comes to this kind of comparison? Extant organisms have almost nothing to do with origin of life.
So does the self-replication factors are ultimately at the bare minimum, and this is Kunin, I believe, talked about this, and he also talked about why it's so stupidly implausible to think this could happen without or just by chance. Even he's an atheist, by the way. You have to have a helicase or a helicase. You have to have ribosome. You have to have DNA, and there's like 4 or 5 other enzymes and functional proteins. You have to have protein machines. You have to have in order for self-replication to occur. So, as an example, just the helicase is 1,000 amino acids long. 1,000. That's just for one component of the transcription factor requirement. You have to have, so that is going to equal no less than 3,000 base pairs sequences in the correct order at the bare minimum for the helicase to come into protein to come into existence. That's before you account for the other components. So now you're easily looking at thousands and thousands and thousands of base pair nucleotides, which can have no errors. They have to all be in the correct sequence. But now you're stuck with the chicken and egg problem of, okay, wait a minute, that helicase that I need and the polymerase and the other things that are going to be used for the transcription, the sequence is in the DNA, but those things don't exist yet. So how in the heck does the transcription occur? That's why it's the ultimate conundrum, which is why it's like, okay, so I have arbitrarily assigned values, I have information, I have prescriptive information that is required to be executed in a specific order by a specific process in order to result in this functional protein. But without that prior existing functional protein, it can't occur. Therefore, I have to argue that somehow the functional protein somehow came into existence in order to enable that transcription process to occur. And
right. Again, though, like I 100% am down with the idea that it's like, all right, abiogenesis with one single organism in one single location with everything being able and ready to organize in that specific way seems unlikely. But again, I keep feeling like we're pulling back to this singular case, this one sequential event, when in reality it's occurring far more times than that.
Even if you
hold on.
Let's make sure Erica gets equal time with one.
Yeah. So again, I get what you're saying, and I'm with you on the idea that it's like in that aspect, it would seem rather astronomically implausible. But again, because of the massive amount of time and space that we're looking at, and again, I'm very clear on the specifics on how it's not simply the organization. It's not simply the right place, right time. You also have to have these applied rules to them. And I guess the thing that I'm struggling with, and perhaps it's just because I'm not a biochemist and I'm not a programmer, but I don't understand why these laws, these rules, these semiotics that are applied to non-intelligent organisms seem so far off as something that could have emerged by chance, given to create even a single organism, all of these things have to be present. Yes, they're in a concentrated area with all of many, in my opinion, if not all of the things that they need right there. It's still going to take a while. That's why it did take so long. But in real life examples, and from a sort of utilitarian standpoint that you were using earlier with the mycoplasma, there are numerous scenarios today and again, I use language as an example, where organisms that are unintelligent behave in an intelligent way and can acquire new means of behavior in unintelligent fashion. And again, it's because of natural selection. And I'm with you, selection isn't acting on something before it's a thing, but in some ways it kind of is.
So what you're talking about in terms of learning a new function, that is the direct result. It doesn't matter if it's a lower level, quote unquote, lower level life form that has some lower level of intelligence. It still already has intelligence. That's like saying that a human learning how to play a piano is not the result of intelligent application of information processing functions which are executed through the brain.
Wait, though, you're confusing, or rather conflating, intelligence with response. Like, obviously an amoeba is not, or any kind of very small organism is not going to be intelligent, yet you can train certain, I guess, even fungi to go through a maze, to grow their way through a maze, because they respond to the stimulus around them.
Right. And how do they respond? What causes the response?
Well, a lot of it's chemistry. I mean,
it's sensors, it's sensor organelles that already exist and are the result of
sensor organelles are picking up on chemistry.
Correct. That's not so the manner in which they're being able to do that is requiring nanotechnology that is housed in the instructions and the execution of which.
How is that nanotechnology, though? It's just chemistry. Chemistry occurs whether an organism is living or not.
No. Okay, so those sensors, those organelle sensors that are, if you blew those up onto the macro level, those would be incredibly complex technologies.
Well, there are many. The Giant's Causeway is a very complex geologic formation that's been subject to a lot of chemical and physical.
The rocks cannot determine and process if they should go in the direction of.
They respond to stimulus.
No.
And if there's the presence of selection.
Sorry, are you actually trying to equate life to rock?
No, what I'm saying
because it's a well-defined element that there is a tremendous difference between organic and inorganic.
Yes, no, I would agree with you. But
okay, so then don't compare it to rocks. Then an organelle
very specific actions. What it is it's chemistry. You just admitted that.
No, I'm actually directly
organelles, but it's still chemistry. That's what you just said.
Okay, no, I
is
said
it not? Correct me by all means.
Are you going to stop interrupting me? Okay, the organelle is a sensor. Okay, it's a technology sensor. Okay, what you're arguing about, it's just chemistry, is like saying that when you hold up your camera and it is able to sense light, that there is nothing going on in order because it accepted light. That's what you're talking about here. The organelles that we're talking about that are the sensors on the the membranes and such, they're enabling these processes. They're nanotech. They're being able to read. We have
literally just not though. Like the mitochondria is just undergoing chemical processes. Like so is any level of cellular biology.
Okay, so you don't. So you think that the ATP?
Equal time, guys. So
are you arguing that
America? And then go ahead, John.
Are you?
So we're kind of talking over each other there. So
no, I get it. It's fine. Tensions go high in these kinds of debates. Yeah, I just outside of John and. Actually, just outside of John, I've yet to see anybody in sort of not even in the bioinformatics realm as of late, like past 3 years, refer equatably to DNA and sort of a computer code, or more specifically, an organelle and nanotechnology. I think it's an original take. I just don't think it's being.
So I don't know what you're reading, because proteins are directly called nanomachines directly in plethoras of papers in very recent history. Like, there's no argument inside of academia of whether or not
you're defining it, though.
Okay,
does it not?
So are you suggesting that ATP turbine is not a nanomachine?
It depends on how you define it, because the Golgi apparatus is technically an apparatus. Does it mean it's the same as a crane? No. Like they're weird ways of categorizing things, of course. But I bet if we sat down, the two of us, and we decided to Skype with a bioinformatics or biochem guy, and we were like, "Hey, do you think it's fair to equate an organelle to a nanobot?" They would be like, "No." Like
I will take you up on that. Let's go find somebody. I'll bet you $100 that I can go and find things on YouTube right now from conferences said by biochemists. That yes, hey, these are not just chemical reactions; these are literal nanomachines. Do
you think they're being hyperbolic?
No, because I've also read papers where they talk about how it is not hyperbolic; it is literal.
Well, I would be really interested to see those. Again, I am open. Okay. This is a subject where I'm just open to being proved wrong, because again, this is not my wheelhouse. But I very much doubt that.
So let me ask you this: so the transport proteins, for example. That use a literal, they bind to microtubules. but they use a process by which they literally walk. And that process was actually copied in a molecular nanocar race that was done back in 2016. They actually looked at the process by which they were able to make this step process occur on the molecular level and applied it to their nanocar. And then they expanded that into creating they looked at the ATP turbine and used the exact same logic to create a axle with molecules that can turn and bind powered by photons. Exactly like what's going on with the ATP turbine.
Yeah, that's super cool. But the thing is,
hang on. So is the molecular car, which has structure, it has turbines, it has wheels that are powered in the exact same process as by the ATP turbines proteins, is the nanocar, is that nanotechnology and a machine? Yes or no?
Is the nanocar in an actual machine?
Is it a nano machine?
I would say the one made by humans. Yes, it is a nano machine.
Okay, so if per the admission of the same people who are creating these kind of things, that theirs is not anywhere close to as efficient as something they were attempting to copy. And it is so much more complicated to build from a chemistry perspective that no, we don't know how to do this because there's so many steps in the process that have to be done in a controlled fashion with specific enzymes, all those kind of things in order to be able to execute what we're seeing in biology. I don't understand how you can conclude that one that has the exact same types of functions, right? This one's not technology, but this one is because it was created by a human, even though humans admit that this other one is way more high-level technology than the one they were, from a capacity perspective, than what we were able to build.
Because the fact that humans can't recreate it verbatim, to me, is almost more supportive of the fact that it is not designed. The fact that you can create something that looks we can create, macroscopic versions of, or rather large scale to scale versions of a heart, but that doesn't mean that it can do all of the same jobs a heart can do, or a liver, or lungs, or whatever. To me, that doesn't necessarily state that those things are designed, but rather they're impeccably complicated. The fact that things are complex and that we can't mimic them, to me, seems like a ridiculous comparison.
Okay, so talking about the heart. Talking about the heart.
So talk for a minute too. So if we were to say, all right, what's a really a perfect example would be like if we wanted to build a very high vantage point. We're like, wow, trees grow really tall. We want to be able to see really far too. And so we try to make something that's super flippin' tall so that we can see as far as we can. Well, Mount Everest is gigantic and has an enormous vantage point to it. The fact that nature made it on a massive scale and that we can't reach that scale, be it because the scale is high or the scale is low, says nothing about its ability that it's designed. The hallmark of design is simplicity. And it takes it back to my entire original point, which was the code is redundant. Now, I couldn't tell you, and I will be the first one to tell you right now, you've given me a lot of stuff to research with the evolution of actual mechanisms of replication and transcription, because I can't give you great answers because I don't know them. But what I would say is that I would be very surprised if I got off this call with you and I went off and I found a bunch of scientists with their hands up saying, must have been intelligent design. I would wager that there are mechanisms proposed for these semiotics that are out there that I don't know about because this isn't my field. But what I do know is that while I can't answer you that question, while I can't tell you how semiotics came about, that the answer is out there. I don't think you can say the same to me, about why redundancy exists in designed organisms.
Okay, so number one, the redundancy that you're referring to, I've already addressed that because we're discovering that it's not negative. So many of these aspects are not negative redundancy. They actually have direct function, number one. So you can either accept that or reject it. Doesn't change the fact that it's true.
Just the papers just don't say that. I said the same thing in my conversation with Standing. Unless you're about to tell me the strict reasons why Grar et al. In 2017 is incorrect in his assessment of the functionality of the human genome, then I don't know what to say. Maybe there are papers out there and you have them and I haven't read them. But I've heard you say there are papers, but then you haven't given any.
Okay, so as I've told everybody, the I have an open folder, and there's papers in there literally titled these things. You can go look at them.
Okay, chat, get on it. You guys got it. Find if you would be so kind.
Hey, I let you talk. My turn.
Yeah, your turn. Sorry.
Okay, so a minute ago, you tried to equate a mountain and us not being able to recreate a mountain as being equivalent to us not being able to recreate something from a biological perspective, and then you finished up with, a hallmark of design is simplicity. Well, that's a very naive perspective, especially when you think about hypercomplex functions. Just because it is complex doesn't mean it's not the most efficient model in order to reach the desired outcome. And just because you don't know how every piece of it works, doesn't mean that they are not having functional outcomes. But in terms of optimization, there's been studies on this that, like the genetic code, for example, which actually is a code. They did a whole study on the fact that it's a code, and the whole purpose of the study was to determine whether or not the genetic code was the most optimal one. Of the million different possible variations they studied, our genetic code happens to be the most efficient in data storage. And they also found out that the redundancies and the different aspects to it also made it the most robust. So we actually have one of the most efficient options. That's interesting. Beyond that, we have things like ion channels and different functions inside of the body, which they are optimal. There is no greater optimization possible.
I don't doubt it.
So we're arguing on one side, hey, this is all a bunch of crap over here, and there is no hallmark of design. Over here, we have something that cannot, literally, from a physics and chemistry perspective, cannot be better.
But why isn't it all that way, John? Why is it random what's optimal and what's not? Why? It's my example.
You're making the arbitrary. Okay.
Why do you have 80 dikes here and 0 where it floods the most? Why aren't there 100 different things that prevent us from getting tumors? Why is it the way that it is?
So again, we are literally, there were papers published. I've mentioned this in multiple debates. There were papers published in January of this year in Nature on the same day, 17th of January, I believe, all about medical research, about cancer and different genetic disorders. And in multiple of these papers, the authors were saying, okay, basically, I'm paraphrasing here, but it was pretty direct language. It was basically, hey, you evolutionary biologist idiots who are consumed with neo-Darwinism, stop claiming that this has no function, because we're finding out that it does on a daily basis. And the reason we don't know more about it is because you guys have been arguing that there is no function. And then if we find it, it will negate your entire theories.
So let me be very clear on.
I'm not done yet. Hang on. They literally are saying things such as, the reason we don't have the technology in order to be able to better document and discover is because there hasn't been the funding to do so. However, now we've made so many discoveries that there is massive amounts of money that's going into it. I think there's a project, I forget the name of it. It's like the secondary level of ENCODE. I think they just got like $4 billion to go into this, because they're realizing all this stuff.
Allow me to respond. Let me get this. I want to make sure I'm getting you 100% clear on this. Are you telling me that this paper, when I go and search it, are going to say that the functionality of the human genome is, Brar et al. In 2017 is wrong, and actually the functionality of the human genome is far greater, and when I say far greater, I don't mean a few percent, far greater than what we have always said it to be? I want to be very clear on this, because I'm about to go read this paper top to bottom, baby. You're telling me to
I am directly stating that there are numerous researchers in a variety of fields.
In this one paper?
Okay, apparently you're not actually listening to the words that are coming out of my mouth.
I'm doing my best, but a lot of it sounding like gibberish.
Well, your ignorance of some of these topics is becoming readily apparent in regards to a lot of these topics we discussed.
You got to put up or shut up on this one and show me this paper that's overturning all of genetics. I really want to see it.
So number one, I never stated it was overturning every aspect of genetics. What I stated, what I stated was that there are numerous papers who are directly, the authors of which are directly stating that there is way more functionality in the supposed non-coding regions of the genome that they're discovering on a daily basis. Number two, what I was stating is not only is that the case, and I'm forgetting the name of the, I'll have to go find it again. I'm forgetting the name off the top of my head of the secondary component of the ENCODE project, which is specifically dedicated to the non-coding regions because of all these discoveries that they're making.
So how many papers is it? How many are we dealing with? Because I want to find and read these very well so I make sure I'm educated next time I have this conversation with someone. How many people are saying that there are far more functions and they need more funding? What papers with these medical researchers? And then which one is the
go to Nature and search non-coding DNA discoveries, and you will find a ton of them.
Yeah, but I asked that. I remember I asked a question.
And I have several in my folder.
I tried that. I tried searching that last time and I didn't find it. Do you think you could do me the favor and maybe email it to me?
I will email you the link to my folder, and you can go find it in the plethora of papers I literally have documented and titled.
You don't know where it is in the folder? You couldn't just email it to me?
I do, but since you don't actually seem to want to consider the arguments other than do anything, then not really.
Oh, so, okay. All right. Well,
because you've been kind of condescending to me today.
No, I didn't turn it on until you did. You know, honestly, I do try to be pleasant in these kinds of things, but I think you're very aggressive, and that's fine. Everyone's got different styles of arguing, but you know, I guess
my aggression is coming from the fact that you are directly dismissing factors that have been well established since Watson and Crick in regards to the genetic code, number one.
I just think you don't have the papers. I think that you've been saying go look in the folder for a long time, and that I know people who have, during the middle of your debates, gone to look for these papers and not found them.
So obviously I haven't read any of the papers because there's plenty of them in there. But are you suggesting that since Watson and Crick, the premise of the genetic code, what is the origin? Hang on. What is the origin of the entire premise of the frozen accident?
You're the moderator, Standing. Go ahead.
So what I want to do, because this has been a very fast-paced, engaging discussion, I got to say, great job, guys. I know it can get heated and passionate at times.
I'm having a great time. I always have a good time in these.
It's been a wild ride. The audience has had a blast. We've had 90 people or so in the chats. So you guys bring the numbers. And to the chat's credit, we got a ton of good questions. But what I want to do, because it's been so fast-paced, I want to give you guys a couple minutes at least just to kind of wrap things up, go over whatever you feel is necessary to sum up the discussion, and just give your final thoughts. If you want to address anything you feel you were not able to in the discussion, you can do that in kind of like a 2-minute closing if you'd like. Since John started, we can start with you, John. We can go to you, Erica, and then Brother Sal's has done a phenomenal job gathering all the questions. There's been a ton, so we're not going to be able to get to all of them, but we've got a lot, so we'll have some fun there. Go ahead, John.
Well, I mean, tonight, folks, has been yet another example of the atheist, or in this context, agnostic mindset worldview of my opponent, who apparently is incapable of recognizing, or unwilling, not necessarily incapable, unwilling to recognize the significance of the things that she is trying to explain through natural processes. There are things such as the genetic code, going back to Watson and Crick, and the whole origin of the premise of the frozen accident was to explain the arbitrary value assignment of the genetic code. This is an unavoidable component. Now, atheists and evolutionary biologists and agnostics desperately attempt to circumvent this and try and claim it's only an analogy because they recognize, or some recognize, the significance of the entire point. If it is actually genetic code, if it actually is programming language, which all of the factors show that it is, then there is no other context in which that could occur without an intelligent agent. When you factor in, from a chemistry perspective, the extraordinary improbability and the number of processes which must be happening simultaneously in order for life to ultimately come into existence, the time factor has zero benefit to the evolutionists. They think that it does, but the time factor has no bearing on whether or not it's actually plausible for these things to come into existence. And you still have to have it accounted for the first point of syntax, semantics, and pragmatics. Then you haven't accounted for the temporal values, the space and the spatiotemporal factors, which must be in existence in the genome in order for life to exist. Then you have to account for the functional proteins, some of which are so massive that you are now arguing that something like the Titan protein, for example, which is 33,000 amino acids in length, over 100,000 base pair nucleotides in a single genome, in a single gene sequence. Somehow, those all came into the correct order with no errors to result in one of the most fundamental proteins that enables life to exist. I mean, and this is just one example. You go on and on and on. The information processing components, it is completely recognized. There is massive amounts of information processing to the extent that at a top-level computer science conference, I think in November of last year, they were talking about how there was a whole keynote speaker on how not only is the genome and cellular biology Turing complete technology, it is information processing, it's not analogy, it is literal. They even went so far to argue that the information processing happening in the cell is superior to what we're trying to recreate with quantum computers. And they're arguing that we should go down that path because it is that much more efficient. So ultimately, in the context of intelligent design, I am arguing that it is not logical, plausible, or probable that information processing systems and communication systems and technologies and engineering and mechanisms and nanomachines which enable life to exist could ever come into existence. I don't care how much time you have in the works without an intelligent agent. If you are arguing that they can, then if you blew a cell up to a macro level, you are talking about something that's bigger than the city of London, with more factories than on the entire planet, and more technology infrastructure and communication systems technologies that are vastly superior to anything humans have ever done. Just because it's happening on the molecular level does not alter the fundamental components and requirements for all these things to exist. That's enough of my diatribe. Thank you for our debate. Glad we had some heated back and forth, and the floor is yours, Erica.
Thanks, John. Yeah, we get passionate, but honestly, it all boils down to a desire to better understand the other person's position and to try to get where you're coming from across to the other person. So while we do get heated, I still had a ball. So from my perspective, though, with regard to John's specific argument, I find it to be a very large argument from incredulity. I am certainly not as well versed as I could be in all of the immense literature body that involves abiogenesis and all of the components that go into it. In fact, I'm more of an evolution gal when it comes down to studying once life is already here. But like I said previously, that was never going to be the kind of conversation that we were going to have from John's perspective, because it's the fruit of a poison tree. And I'm glad we got to have this conversation. I got to get out of my comfort zone a little bit, and now I have a lot more reading that I can kind of get into and learn more about. But when it gets right down to it, you just got to look at the literature body and take the time to go through the various hypotheses, because there are quite a few. This is an area of science that I'll be the first one to tell you. We don't know as much as we could know about it. And that's part of what makes it so cool. And that's just kind of my thoughts on it, I guess. It doesn't really get too much more complicated than that. Of the papers that I've read, none of them seem to be very problematic in the light of what John is saying. I mean, I Googled just now, just for fun, is DNA like a computer code? And the very first thing that comes up is DNA is not like a computer program, and preceded by several smaller bars kind of going more in depth on that. So I do want to get more in depth into that on my own in the future and articulate my arguments a bit further on this in particular, and look into the biosemiotics of how the people who know far more than anyone in this chat and in this talk here ever could know, or maybe not ever could know presently, because they've done their doctorates and things like that on that. But yeah, I'm looking forward to learning more. I just don't find the argument that John presented for intelligent design here particularly compelling. I just think it's a lot of irreducible complexity, arguments from incredulity, and a bit of, and I don't mean this in a disparaging way, but sort of a hand wave of the factors that I find to be very important in the process. And that's pretty much all I got for you. I did have a good time. It's not very often that I get to get a little bit heated, but better to do those kinds of things when we're all just trying to get to the same place and learn more.
I agree. It was definitely a lot of fun. I'll tell you, one to remember. Thanks for making it fun, guys. So I want to thank Brother Sally. Had a tough job. We got a lot of questions, super chats flying in. So what we'll do, And it was a good idea from Sal's. We're going to acknowledge the super chats first, and then we will get right into the questions that Sal has gathered. So go ahead, Sal.
All right. Well, I'd like to tell the audience, Erica and I go a long ways back, and when she was on some of the Reddit subs, including some of one of my own. But at the time, I thought she was a guy, so it was a shock to find out Gutsick Gibbon was Erica. So first super chat is from Modern Day Debate. He says, "Congrats, Erica," and he said, "Hit like, peeps." The next super chat. Yes.
Liked myself.
I'm sorry?
I said I just went and liked it myself. I'd forgotten to hit like on the debate.
The next super chat is from Bond, George Bond. And he has a question for Erica. If the RNA from clay is the most probable, why is it that they are now suggesting in a paper that it is probably both RNA and DNA come into existence at the same time? Before you answer that, why don't I just acknowledge the other super chats?
Yeah, sure.
And I'll queue up those questions for you, just so we can recognize these fine people, since it's been a long discussion.
Yeah,
Jeff Lynn, did I mistype that? Oh, wow. $250? Maybe I mistyped that, but if you did, thank you. And we can send Erica a nice wedding present. SFT, buy a coconut for raw mat. And from Smoky Saint, GBU SFT, thanks for the support today. From Coco Puffer, Erica, this was one about UB dating, but thank you, Coco Puffer. So I'm going to queue up 2 questions there. And Ian Chen says, Erica is super awesome. I already know she's one. No, so there you go.
Ian's a good guy.
All right. So shall I just go ahead? I'll read George Bond's question since he was in the super chat.
Yeah, absolutely.
If the RNA from clay is the most probable, why is it that they are now suggesting in a paper that it is probably both RNA and DNA come into existence at the same time?
I don't know of a paper that suggests that they come into existence at the same time. It sounds like a cool paper. Maybe it's new and I haven't seen it. As far as the clays go, to my knowledge, it isn't that the RNAs come from the clays, it's that the clays allow the RNAs to more easily self-organize. So if this second paper is the more viable hypothesis, it could still exist under the lens of clay assisting in RNA self-organization.
Thank you. And then Coco Puffer, Erica, UP/PB, that's uranium lead dating, assumes no PB, that is lead, is present at the formation of the zircons. Have you read the paper published in PNAS showing PB present in zircons devoid of uranium?
Yeah, I think I get what you're going with here. No, I haven't heard that. I haven't read that paper. It sounds like an interesting one. I would be interested to see if whichever way, like when they're looking at this, because typically the way that radiometric dating works is they corroborate numerous methods across with one another. If it's a mineral of any importance for determining the date or age of something that is vital in the geologic column, vital for the study that they're doing, typically they'll cross-corroborate with more than one method. So I would say that if in this particular case, this paper is 100% correct, and occasionally we can have trace elements of the daughter parent where they're quote unquote not supposed to be at formation, I would be interested to see if that applies across the board with elements, because as far as I know, it doesn't. And more importantly, in this specific paper, how much was found, because I think it's very easy to point to sort of novel findings and apply them across the board. But the tricky part comes when we're analyzing it in depth and trying to figure out why it is the way that it is. Case in point being what factors could perhaps contribute to that. Anyways.
SFT, I'm just going to farm out the questions. If you want to help me handle the back and forth, if there's any, that'd be appreciated.
Of course, yep. No problem.
And so from Oh, yeah. There are 31 more questions now.
Whew.
From Spart 344, open question. What kind of an off day was the designer having when he designed the human reproductive system and the wind plus food pipe? I think that's a rhetorical question. So I guess no answers.
If I think
He's having a fun day. He's pretty mischievous. That's just my opinion.
A little
Sorry,
mischievous.
I shouldn't be.
personally, I think if you actually dive into the reproductive system and the processes that are occurring in order for it to happen, it's actually rather exquisite from a functionality perspective in terms of what is actually happening in the zygote itself, and then how that ultimately results in a human. It's pretty amazing.
Richard Dawkins has a fun quote. I'm not a big Dawkins fan in most ways, but he does make a good quote. And once when he was being asked how an organism how all life could evolve from a single cellular organism, he was asked by a young woman who said, "How is it possible that could happen in billions of years?" And Dawkins looked at her and he said, well, you did it in 9 months. Which I thought was pithy and funny. I don't think he was meant to be taken literally, but I did find it to be a funny quote, somewhat relevant to the question.
Well, quick counterpunch to that. So you do realize in the mammalian or in the more advanced life forms that are sexual reproduction, which is such a foundational piece of evolutionary theory, you do recognize that the mutations have to have occurred in either the sperm or the egg, right? And it has to have occurred in the sperm or the egg that gets fertilized.
The evolution of sex and sexual reproduction is a fascinating conversation, but I fear if I answer that, I'm going to go on a bit of a tangent because once we get into macroscopic stuff, baby, I'm chomping at the bit.
I'm not talking about how did sexual reproduction come into existence. I'm talking about the actual supposed macroevolutions that you're talking about. Those mutations had to have occurred in the sperm or the egg.
Why could they not?
Because it contains 1/2 of the whole of the recombination, right?
You realize that there are mutations that occur today and only occur on the egg or the sperm. I don't understand why that's a difficult.
No, I get that. What I'm saying is every single mutation would have had to have occurred in a sperm or an egg.
I reiterate
in the outcomes. You've lowered your opportunities to such an extent that the probabilities of all this just become ridiculous.
I'm telling you, John, it's an.
I know you got.
Go ahead. Next question.
We got a lot of questions to go through.
Okay, next question. Sorry to cut you all off. This is really more for the service of our faithful listeners and viewers. Jungle jargon. How do you get high intelligence from no intelligence?
Oh, that's very similar to the conversation that John and I were just about to have. I know quite a bit about cognition in primates and how cognition scales across the primate order. And a lot of it comes down to how complicated are your social systems. So when you reach higher levels, it comes down to maintaining sociality and things like that. And we can track this based off of the sizes of baboon troops to a degree. As far as the first intelligence, I think it depends on where you draw the line for intelligence. Like I was saying to John earlier, certain kinds of sponge molds can navigate a maze if you give them enough time. Does that make them intelligent? Well, no, they're doing response stimulus and managing to grow their way around walls and get to the food source that they can pick up on. So it's a difficult question. It depends on where you draw it. What would be the first intelligent, quote unquote, organism? I don't think it's a line that you can draw. It's certainly not one that I can draw.
Okay, I'll go to the next question. Interrupt me if you feel you want a little bit more time. To John from Luca Medugno from Italy. I think that's one of the guys from Europe here. We have people from all over the world. And his question is, how can you tell that abiogenesis was just a random process? Maybe a chemical pathway exists, one that can explain the phenomena. And that was directed at John.
Well, at some point you have to recognize that we've been staring at this chemistry for quite some time now. And what it's boiled down to is that somehow all of these things had to have come into the correct order through an undirected process if you want abiogenesis to occur, and arbitrary values have to be assigned also through an undirected process to result in a controlled, structured outcome. And what is being argued in abiogenesis is that, hey, there is a minuscule chance that absolutely surpasses anything else from a probability perspective that would be considered remotely plausible. It surpasses Borel's law. It surpasses the law of small probability or chance probability, which is 1 in 10 to the 150th power, equaling 0 from a universal scale. 10 to the 50th is on a Earth scale, being 0. But no, due to laws of large numbers, that this could possibly happen. Well, you know what? At this point, it's like saying, oh yeah, cool. There's a chance that I could pick I could win a lottery that has 20,000 numbers that all have to be picked in the correct order. And yeah, I'm going to be able to win that. I mean, it gets so ridiculous to the point of, yeah, bro, if you win that lottery, I'm going to immediately start an investigation into how you cheated. And that number of 20,000 numbers to winning the lottery isn't anywhere close to what's actually required to have happened in order for abiogenesis to have occurred. So, I mean, just because you can say, oh, if we have enough chances, this might happen, does not remotely make it a plausible scenario. As in my debate with Ron Garrett, he said, oh yeah, well, from an information theory perspective, it is actually possible to come up with a chance probability of a piece of iron turning into a sword. Now, that doesn't mean it's plausible, but you could still come up with an equation. And that's exactly we're talking about in the context of abiogenesis.
Okay. Everyone okay? Next question from James Downard. Question for both debaters. When did life first appear? What did it consist of? And what happened to it next? That's for both of you.
I just ranted. Go ahead, Erica.
Oh, I can go ahead. I mean, I kind of said it in my earlier. I'm trying to switch back. There we go. I said it earlier in my conversation with John. I mean, from my perspective, according to the current literature, which might change as science does and should, I think, if new information comes along, you definitely want to change your ideas on it. I think that's the hallmark of a good field. But from my perspective, we're probably dealing with something in the hydrothermal vents approximately 3.8 to 4.1 billion years ago. We see probably the formation of lipid encapsulations forming first, followed perhaps either by proteins or sort of our nucleic acids. I'm not sure. Again, I cannot emphasize enough how this is not my field. I do my best when the conversation goes in an area or is planning on going in an area that I tend not to know about, but I think you would have to have a pretty good sized degree to understand the inner mechanisms of the current literature on this in its entirety. But I think what happened to it next, well, replication is the hallmark of life, one of the hallmarks of life, along with like responding to a stimulus and doing all of those things. So I would wager it started reproducing, it started dividing, or it started consuming, depending on what kind of organism it is, if it's like a methanophile or whatever. But I think it's going to be interesting to find out more.
Okay, the next.
Sorry, to me too. I mean, the entire premise of Downard's question operates on the idea that somehow life could come into existence in a non fully formed manner. So my argument is that the entire point of the intelligent agent being required is that a fully formed model must come into existence simultaneously. All the factors must come into existence simultaneously. And then when you look at this from a bigger perspective, and you look at the elements of design structure across all forms and the barriers to macroevolution being even remotely plausible, fully formed structure of the different lines of animals is the logical conclusion.
Okay, the next question I think is more or less rhetorical. Gavin Herleman. Why do atheists like Tom Jump insist that DNA is created by RNA? Okay. Yes, we don't have to answer that. Okay.
Probably because there used to be origin of life researchers that tried to argue that, and then they came to the realization from a chemistry perspective that was not remotely plausible and had to give that one up. But people like T-Jump still cling to some of those models.
Okay. I'm a co-moderator. I can't make snide comments. Sorry. Bill Morgan, question for Erica. Do you think crop circles are most likely the result of design or chance? And what criteria do you use to determine?
I think that crop circles are probably the product of design. I think that when it comes to determining a design from a non-design, a lot of it comes down to efficiency and simplicity versus redundancy. And a lot of it comes down to, is it something that can be selected for and can reproduce, or is it not? Which is fundamentally why, when in sort of John's example, when he was talking about making a nanomachine that mimics cellular structure, to me, that doesn't really say anything other than we copied something that self-replicates. I mean, and sort of made a human version of that. The parts of our nanomachine, nor can our nanomachine itself replicate on its own. So for me, those would be the hallmarks. That's why I want criteria for design. Like, so very frequently these conversations, and I fell into the same trap today, fall into critiquing the evolutionary model rather than saying, well, what's the creation model? What would the first design look like? How does one determine design from non-design? Because we know that creationists accept sort of evolution to a degree, as long as it's within the kinds. So how do we determine what nature makes versus what God made or what humans make? But I didn't push on that, and it ended up being a conversation about my model, or conventional sciences model, which, c'est la vie, maybe another time.
There are several questions from also James Downard and Bill Morgan. What I'm just out of courtesy, I'm going to actually try to get to some of the other questions first from other people. Chris Keith, ask Erica what process she believes allow for the irrefutable soft tissue we find in dinofossils. How does she think osteocytes, bone cells, survive for millions of years?
Ooh, I'm going to direct that person to my video on Mark Armitage on that. I cover extensively how plausible I think that it is that osteocytes with a half-life of approximately 22 years could survive in a dinosaur bone for several, maybe a couple of centuries, let alone millions of years, because I don't think that was one a Triceratops horn, and also I don't think that even if it was a bison horn, which I think it is, likely a result of contamination, which we see frequently in the conventional field and has to be controlled for, but we lack the methodology to understand exactly what was going on with Mark Armitage's work there. I would say, as for the soft tissue, I hear that one a lot from creationists, and they don't tend to keep up. They meaning the ones that I'm interacting with anecdotally. Maybe this person is different, but they don't tend to keep up with the work of the actual progenitor of that work, Mary Schweitzer, on her various preservation methods, nor on her colleagues' preservation methods, which propose a series of different mechanisms kind of working in tandem, and they seem to work quite well experimentally. So I would encourage them to look for that, and if they want, they can email me about it, and I will give them all the sources that I have for it. gutsickgibbon@gmail.com, all lowercase.
Thank you. And the next question is Leophilius. I have a question for John. Is all genetic material made of natural chemicals? Does it all operate under natural laws? If so, where's the implication of anything supernatural?
Yeah, it does. So does a hard drive, and magnetic hard drive. It's using the laws of physics to store information. However, nobody would argue that the process by which magnetism is used in chemistry, in some aspects, is used to store that information could ever occur without the intelligent agent. So if we're talking about and this is the point I've made many times, and apparently people who believe in some people cannot seem to grasp this premise, that the medium which contains the information and the processes is completely irrelevant to the origin source requirement for that prescriptive information. It blows my mind how this seems so difficult for people to comprehend. I write down instructions on a piece of paper. I take a picture of it. I upload it to Google Drive or to an email, which I send to Erica. She then downloads that and prints it out onto a new piece of paper. That thing has just gone through 4 or 5 different states of the information being contained. Now it's back on a piece of paper. However, there was still information that was required. The medium which contains it has zero relevance. There was chemical processes as a result of me taking a pen and the ink binding to the paper. That has nothing to do with the origin of the syntax, semantics, and pragmatics, which are now being delineated onto that piece of paper through a chemical process and then translated and transmitted via encoded and decoded through electronic transfer. This is exactly what's happening in all aspects of biology, and why I don't think anybody would conclude that what I just described in terms of what I did to send directions to Erica could ever be accomplished without an intelligent agent.
Okay, with 4 more questions, we'll actually get to all of the readers before we start to repeat. So let's see. The next one is from Dapper Dino. The question is for both. How does the recent discovery of persistent ribose in asteroids impact your ideas about abiogenesis/ID?
I can go first on this one. I think it's super interesting. The panspermia idea has kind of been poking around in the abiogenesis community, for a while now. And I say that as someone who's barely involved in the abio community. But I think it's very interesting. We know that ribose is it's pretty important for early life in many different capacities. Sorry. So I think it certainly says a lot about the ideas that at least some components may have arisen from the stars, which is weird and kind of woo to say, but the paper's pretty interesting. I think everyone should go and give it a read and see what they think. I don't know what I think. It could mean a lot of different things.
Assuming it's the one from last year, there's 2 things about that. One, okay, they may have seen some amino acids. They think that it might be a protein, not 100%, but what often gets glossed over is the fact this asteroid that they're referring to crashed into Africa, I think back in 1989, and they didn't, quote unquote, discover this protein until literally 30 years later. And we know full well that Erica was talking about this in terms of contamination. It's also not a completely unrealistic or implausible and improbable outcome that this is a result of contamination. So I know there's excuses on that whole deal, but just either way, it doesn't really affect the requirements for abiogenesis.
Okay, the next one is from Mitchell. A question for Erica. Which one of the 4 RNA nucleotides evolved first, A, C, G, or U?
I don't know. I think that's a really good question. I think that's one of those questions that even if you're like totally on board with the conventional science, as I am sort of, I don't think that's a question that we would be able to answer because we're never going to know the precise conditions of the prebiotic Earth. I think you can get close, and I think you can get a pretty good idea about what's going on, but I'll be the first one to tell you we'll never know precisely with 100% certainty what happened. A lot of paleontology and a lot of sort of origin of life studies is like playing forensics. It's looking at what we know now and trying to see if we can apply it to the past and see if maybe conditions were conducive to one thing or another. So I think a lot of it is just going to depend on what we learn in the future. But I would wager that that's not something that we can know. And therefore, I have no idea. So I'll pick guanine.
Okay. From TD Lane. What does this is to you, John. What does Maddox mean by body plan?
In the general sense, the different body structures and the morphology changes that have happened, i.e., the difference between a whale body plan and a lion. It's rather obvious in terms of body plan structure. But I don't know if that answers the question. I'm getting pretty tired. I've been talking for like 5 hours straight now.
Yeah, it's a double header there. I got 2 more before we want to go back if we have time, but I do want to get to all the questioners. This one's really a comment. This is from our youngest participant, Guzman 1611. Excellent dialogue tonight to both. I disagree with Erica, but excellent back and forth. And our last one, John claimed that no errors are possible with helicase. However, UniProt shows greater than 50% sequence identity, produces equivalent protein function. How does he move on from being so wrong? In point of fact, I feel that such an obvious error should be seen as disqualifying in a debate. Did he research the claim before making it and lie, or not research it at all?
Who said this?
CRISPR-Cas9. I'm sorry, CRISPR. I forgot to mention your name. That wasn't good.
So he's suggesting that 50% of the amino acids can be incorrect in the helicase, and it'll still be a functional protein. Is that what he's saying?
I'll just read it verbatim. He can explain himself, I guess. John claimed that no errors are possible with helicase. However, UniProt shows greater than 50% sequence identity, produces equivalent protein function. How does he move on from being so wrong? So I'm not going to
let's have a debate on that one, because I'm pretty sure you're full of shit on terms of what I'm actually talking about in terms of the error requirement or possibilities. So let's have a debate, bro.
Well, I was talking to CRISPR in the chat, so that he's happy. I've discussed many times with CRISPR. I think that'd be a good debate discussion. So that's something we can work at setting up in the future. So, sorry about that. Go ahead, Sal.
Oh, well, probably a number of requests by James Doward for documentation, and he said, make sure John specifies the paper he's alluding to in Nature. And
yeah, Downward, as I've told you many times in our debates, and I literally put it in the preface of my openings usually, if you want to find the technical literature, to use your jargon, that I refer to, go to my folder that I post on a regular basis. It's actually on my About section on my YouTube channel. It's under the title of For the Annoying People. And go read through the plethora of papers from which all of my arguments have been derived.
Okay, let me just appraise you, SFT. If I went back and started going through the other questions now on the second round, it'd be about another 10, 15 questions.
No, it's been we could probably go for 10 hours, but it's been a really, really fun 2.5 hours. But, to the debaters, you guys have been on the ball for full long. John, you've had a doubleheader, so I think we're all probably getting tired.
Actually, it's really, I've been talking for 5.5 hours, actually.
You're a champ. Well, to the both of you, thanks so much for giving us your time. And
Absolutely.
It was a good debate.
Champ, he's been to at least three debates and discussions today, including mine.
It's been a busy day.
Yeah, for John, if you would like, I have another friend who would love to chat with you about Origin of Life, I think, Dan Sterndale. He's in the chat right now as Creation Myths. He's issuing a challenge. If you would be so inclined.
Creation Myths. Isn't that the professor that you debated, Sal?
Yes, and we're still trying to. Short advertisement, and we'd like to thank Erica for giving us advertisement, because I think a lot of the people that came out to our first debate actually came out to see her, and
Wow.
And I saw some Twitter feeds, and a guy said, "I'm so heartbroken. Erica is only going to be the moderator." So
well, you can only imagine how heartbroken
Erica.
Well, that person's going to be crushed now that if he finds out that Erica's now engaged. That's
So,
his heart is now broken. She's not showing up and is taken off the market. Oh my
I
God.
know.
That's what you were doing.
I'm excited though. I'm going to be. I would love to I'll shoot another tweet out too when you guys are getting ready to have that debate, because I know a ton of people would want to be aware of it just for the content. Sure. I appreciate the flattery, but genuinely, I think most everyone's just there to hear the good talking points.
So just a little bit of free advertising. We've tried to contact James. We haven't been given a slot yet, a date. Just my speculation, I think the whole Matt Dillahunty and Ray Comfort thing probably just overwhelmed James, and that's overshadowing everything. So that's this Wednesday. But Professor Cardinal and I are still waiting to be scheduled, and we're hoping we would really be honored if Erica would be our moderator.
I would love to be there. I want to have it on Modern Day Debate though, because you'll definitely pull more viewers there. You know, James's channel is awesome, and I'd love to help get as many people watching as possible. I think it's going to be a really fun time.
And if you haven't seen round 1, go check it out. That was a great debate.
Yeah,
really good dialogue.
Oh, right. You can actually. You can also go to www.evidenceandreasons.org, which is my new website, and there are links to it. And I'm building out that website. And I'm not much into debate. I prefer lecturing. And I'm hoping to put more stuff on there. So
yeah, absolutely.
Well, whatever we can do to get your name.
Thanks for letting me make the plug there, SFT.
Well, for everybody who's considering whether
anybody wants to plug away.
For everybody who's considering, the watching round 1 from Sal and creation myths, you have to just remember that you've got 2 hyper nerds that are being all nice and dialogue-y back and forth to each other, and I just agree with your position, here's why. Me and Erica are here talking trash to each other.
We're talking trash.
It's a totally different dynamic of street fight versus academic interaction.
Tonight was more like a Rocky Balboa versus Ivan Drago. So it was
oh my goodness, I got to tell you
about
that. There was one guy in the YouTube comment. He said, "I was in nerd heaven." He was hearing us talk, and then people kept talking about Nate Thompson. Then I saw him debate. He's arguing for flat Earth. I said, "I think that guy would crush me." Debates are not all about facts. It's also about style. I think that guy would just totally bulldoze me. So.
Well, and the irony, though, of the flat earther community. So SFT and myself were all lined up to debate Team Skeptic and Fight the Flat Earth. They canceled the last second. I think they bowed out, but we'll see what happens. Anyway, we were not going to be debating the flat Earth because I'm not a flat earther, right? However,
you're not a flat earther. I am.
However,
flat Earth reveal.
However, the ultimate irony was that. I did a live stream. SFT hopped on. We kind of bitched and moaned about the fact that they backed out of the debate a couple hours prior to the launch.
I was up all night preparing. So
SFT is coffeeed out of his mind and ready to rumble. Anyway, so we did a little live stream. We talked some trash about it. All these flat earthers come and comment about how we're denialists. And I'm like, are you idiots not paying attention? We're not going to be debating the flat Earth. We're debating intelligent design. Idiots. Then all the anti-flat earthers came and started accusing us of being flat earthers. I mean, I'm like, what is going on? Neither one of these sides, the Globers and the flat earthers, neither one of these people actually used their brains and actually listen. They didn't watch the video.
And we were
literally talking about, we're not debating flat Earth. It's cracking me up.
We can all agree here, and hopefully in this conversation, that the Earth is indeed a globe. Can we?
Yeah, I mean, I got no problem with that.
I don't know, Sal. Are you a
spheroid
flat earther?
Oh my God, a spheroid.
I'm sorry, that's nerd heaven. I worked in the aviation industry, and they said, no, it's not a sphere, it's a spheroid.
Okay, I stand corrected.
Well, nothing to fear but the sphere itself.
One of the things on my bucket list is to recreate the Red Bull challenge, where the guy went up in the helium balloon, set the record for the height, and then jumped off literally from space.
Yeah.
I'm like, man, if you're gonna die, talk about if it fails, talk about the coolest way to go out. You jump off. It's like a scene from the original Superman movies. You're now, Christopher Reeve in the Superman costume, got the Superman theme song playing as you drop off and observe the curve of the Earth. Man, that'd be awesome. Let's see. That'd be cool. I'm jealous
I think
of that
that's what
guy.
the flat earthers are doing. They're trying to get someone to put them up to prove it's a globe. It's just a ruse so they can get a free trip.
Well, there was a flat earther last year who
Yeah.
had built a rocket, and he died
I remember.
trying to ride his rocket off to prove that exact point. It
I
exploded.
shouldn't laugh. Sorry.
Yeah,
It's
I remember
tragic.
that was a bummer. It was a bummer. It was sad, but at the same time, like, it's kind of a weird situation. Like, building your own rocket just seems like a bad move.
I did that as a 16-year-old. It exploded in the backyard. I was in the hospital 2 days. I still have a scar on my chest for it. So that's my little mischief. So,
Well, not too many people can say that they've attempted to build a rocket.
and
I can barely change a tire. I'm not building a rocket anytime soon. Okay, so we could probably go at this all night, guys, but anyone else want to plug away anything we can do at Standing for Truth to, help you guys out? If the debaters wanted to plug their channels real quick before we call it a night. And Brother Sal, great job with the questions. You did a really good job with that question and answer period, so I appreciate that.
Yeah, absolutely. Thank you, Sal.
you're welcome.
So if the debaters had a couple final words, wanted to plug in their channels, and we will call it a night.
Oh, plugs. Okay, yeah, Gutsick Gibbon. That's just it. That's the whole deal. I don't know who's or if we or you guys or who is running an after show, but I think there might be an after show on my end. It'll probably be on Dapper's channel. If it is, that's my usual guess. He's the usual suspect. So.
My channel, just search logical, plausible, probable, and it'll come right up. You can search my name, John Maddox. Go check it out. I may do a live show, or afterwards. I'm probably not, though. I'm getting pretty tired. I'm definitely gonna do one tomorrow. I've been up since 3:30 a.m. and I've now been talking since 5 o'clock. So I'm probably gonna go take a nap. But definitely for sure we'll do a live show about this tomorrow, and may hop over for a few minutes over to.
John, if you have a coffee, you'll be good for another. One last thing I've seen in the chat, Phil KO, he was asking creation myths, if he's got any other debates planned. So yes, a round two, hopefully soon with Sal. And me and him have been coordinating through emails for the last few days. We're pretty close to confirming a debate between him and Ken Hovind on this channel, so that'll definitely be one to remember. So yeah, this month we've got a lot of good debates planned, and this one was definitely one to remember. So on that note, I'll hand it over to Praise, the amazing producer. Praise, thanks for sticking with us this entire time. You can shut her down.